out-of-the-box way to do it. So now to look a little bit into the code, and this again is a little bit specific on Java, what I have is on my Jetty startup, I just plug in the Java agent that's going to collect the OpenTelemetry data, and that was the only thing that I did to my application. Now, you have the OpenTelemetry collector, and this is going to be the same for every language or library. And then you'll see, let me just increase it a little bit. Oops. OK. Now you'll set up some configuration from the hotel collector, right? And one of the configurations you'll see is the exporter. I'm saying, please put all the information into Jaeger, but let's just say that you wanted to use Grafana or Splunk. You'll just come over here.
This will just take a few seconds to build. And now we have our Java application. Now the end result ends up in target Quarkx Quarkx app Quarkus-run.jar. And boom, it started in 1.3 seconds. So that's a full JVM app with transaction support, with Hibernate, with a database. And it just starts almost instantly. And it includes like Flyway creating the schema in this new database. Now, we can actually get it to start even faster than that if we compile to native, which it could do by running mvn install -p native. But that will take a few minutes that we don't really have. You don't want to sit here watching my computer's fans go. So I've actually prepared one of these in advance. So if I just run my Jnation22 executable, boom, it starts in 0.2 seconds, most of which was Flyway sort of verifying the database schema. So yeah, and that's pretty much it for this to-do demo. Hopefully it's sort of shown you the sort of workflow that you can get with Quakus and how Quakus just goes out of its way to make your life easier by removing as many impediments to productivity as it can, by removing boilerplate and just giving you tools that give you instant feedback.
Thank you. That was impressive. So why are we talking about trying to reduce the memory usage and startup time? This is because nowadays, when you deploy your applications, you deploy them on the cloud. And when you deploy them on the cloud, these things matter because they end up being costs. So traditional applications used to be monolith, and when we made the move to microservices, we replaced a monolith with about 20 microservices, or at least dozens of them. If you go all the way and replace your monolith to lambdas and functions, then that amounts to even more of them. So it becomes important that also when you deploy to the cloud, you're able to scale to 0, and then startup time becomes an issue. You want your functions to start as fast as possible and be as small as possible in terms of memory usage. When you look at traditional enterprise Java, that was something that was designed for 3-tier architecture, where everything was running on top of an application server. So if you had multiple applications, they would all be using the same application server and run on it. Now, this is not how we deploy applications nowadays. The way we deploy applications is that we have microservices, and very often those microservices are written in using different technologies. So you would have one of them written in Node.js, another one in Java Enterprise, another one in Microprofile or Spring Boot, and you orchestrate everything on things like Kubernetes. Now, we need to talk about the hidden truth about Java and containers. When you talk about the memory usage of the JVM, it turns out that a lot of the memory that you're using is actually used by the metaspace. So you have two overheads when running on the JVM. You have the startup time overhead, which depends on the number of classes that you have loaded in your application, on the size of the bytecode, and the just-in-time information, and the just-in-time compiler. And you also have memory overhead, which also depends on the number of classes that your application has, and contains a lot of metadata. The more classes you load in your JVM, the more metaspace they use, which is the area reserved to describe those classes to the JVM. And once you add anything to that metaspace, you can't actually remove them. So you want to make sure that you have as few classes as possible in your JVM to be able to use the maximum of your Java heap. Compilation also adds a lot of usage to the metaspace. So if you try to compare applications depending on if you compare the hotspot and traditional Java applications running on the JVM to Node.js and Go, traditionally they use a lot more memory, and so you would have to have very much fewer instances of the JVM running on the cloud as you would have Node.js and Go. One of the goals of Quakus is to make sure that you can actually get a lot more money, a lot more
bang for your buck.
Bang for your buck, and run more Quarkus applications because they're smaller and they start up faster. So then it becomes competitive with Node.js and Go runtimes. So how do we do that?
Well, it's not just marketing speaks. Quarkus's whole architecture has been designed around starting fast and using less memory. Now, when you think about how a normal Java framework starts, traditionally you have your build time, so Maven and Gradle builds the application, and then once you've built it, you try and start it. So the first thing you'll do is something like loading configuration files. They might be YAML or XML, which means loading the XML parsers as well. You also need to scan your class path to figure out what annotations are present, because Java tends to be fairly annotation heavy. So at startup, you need to look through, find all those annotations, and basically take stock of them. And once you've then got all this information about what your application actually is and what it's supposed to be doing, you need to sort of build an internal meta model that represents that state. So if you've got a web mapping and an annotation, you need to actually set up your routes that will handle that, and basically set up your internal meta model that corresponds to all the annotations and configuration that you've read. And then once you've got that, you actually need to start all the services that let you service requests. So things like opening sockets, starting thread pools, all the bits that actually process requests. Now, Quakus does this quite a bit differently. So we have our build time, same as anyone, we get built via Maven, but then the Quakus Maven plugin actually does a lot more. At build time, we try and do all these other steps as part of our build time process. So we'll read all our config at build time, except for specific values that are runtime configurable. So things like JDBC URLs you can configure at runtime, but things that are more application specific you can't. We'll also do all our annotation scanning at build time. So we basically take stock of exactly what's in the application, and we know exactly what is going to happen at startup. And then we generate our own internal meta model, and we write that out into the application as basically a sequence of bytecode steps that represent just the minimum amount of work you need to do to start that application. So then when we go to actually start the application, all we need to do is run those steps that we've already configured, and that lets and that's basically the fastest way to start an application. And this actually gives us an additional benefit as well. So Steph was just saying that the more classes you load, the slower things are to start, and the more memory you use. Well, all this processing back at the first part here, that uses a lot of classes. And because we do all this at build time, none of these classes actually make it into the final application. So we don't have to load them at the start, which takes time, and we don't have them sitting around in memory for the life of the application. So this is sort of the key to Quark's architecture that actually allows it to be smaller and faster than traditional frameworks. So what we call this is really a closed world assumption. Previously, applications could kind of be configured more at runtime, and you couldn't really make these build time assumptions. But with containers, that's not really the case anymore. When you put something in a container, it basically becomes immutable. So building your application to be immutable and then putting it into an immutable container actually makes a lot of sense. Yeah, and we get a lot of benefits from that, as we just don't have to do as much work at runtime. So this is kind of what the Quarkx architecture looks like. We have all our Quarkx extensions, and they just sit on top of a small core. Now, Quarkx is basically a a framework where you need to pick what you want. We don't package all our extensions into one thing and you just pick which ones you enable. If you want a feature, you need to explicitly select it. And that also helps keep the code size small because you're not paying for anything that you're not actually going to use, and it doesn't actually end up in your application. Now, this architecture diagram doesn't really tell the full story because really it looks more like this. For every extension that you have in Quakus, there's actually two parts. There's a deployment time part that will do things like the annotation processing and try and figure out what needs to happen at runtime. And then there's a runtime part that will do things like actually servicing requests and making the application run. And then there's kind of a core deployment framework that does all this processing. It uses some libraries we've written called Gizmo for generating bytecode, a library called Jandex for efficiently reading annotations. But all this code just stays at the deployment side. And at runtime, we just run our recorded startup time. We have a very minimal core runtime and just the bits of the extensions that are actually needed to make your application run. Now, Steph's going to talk about this next bit, and this is about how we deal with native images and compiling Quarkx applications down to native executables.
So, to do native compilation, we rely on the Graal compiler, which is a rather huge project which has lots of bits to it. It allows you to run Ruby, JavaScript, and even generate some LLVM bytecode. But the bit that we're going to focus on is the bit called Substrate VM, which is the native image tool that, well, we didn't actually show it, but that's the thing that would melt your CPU. And for a good reason, because it compiles things on all the cores. It's very efficient. So the way this works is that you have this compiler that will take your Java application classes, would also take the JDK classes, and then it would have a bunch of substrate VM classes as well that describe exactly how to map certain cases of how to special case certain classes into native code. And it takes all this, and then it's going to run with a closed world assumption and look at your bytecode and try to start from your application and try to see everything that is reachable. And so it's going to eliminate a lot of dead code. And one of the big reasons for that is not just your application, but it's also your dependencies, because you know, when you have a Maven application, you have hundreds of dependencies, even if you're using Quakus. And you don't have just those dependencies, but you also have the JVM. The JVM needs to be packaged in your application. And you don't want to compile the entire JVM to a native executable. There are lots of places, parts of the JVM that you are never going to use. So it's going to traverse your bytecode and remove all the bytecode that you're not actually using, and only compile the small part of the JVM and of your dependencies that you need, so that your compiled executable is going to be small enough to actually be useful. Now, there are a number of things that are a bit different when you're running on native image. For instance, you have a number of things that are not supported, such as dynamic class loading. So as I said, everything that is not noticed at build time is going to be dead code eliminated. So you can't really load dynamically classes at runtime. But this is something that we avoid anyway with Quarkus. Well, you don't have invoke dynamic and method handles, but that's not very important. Security manager is not very important either. And you have things that are OK, but you have some caveats, such as the usage of reflection, because you can use reflection, but you need to mark which classes need to be enabled for reflection. And the reason is that we don't have the class bytecode at runtime, so we need to generate some information for reflection libraries to be able to use them. And so what Quarkus does at build time is that, depending on the framework, if a certain framework knows that at runtime we're going to need reflection for a number of classes, it's going to record that and tell Quarkus, OK, I'm going to need reflection for those classes. Please produce reflection information for native compilation. The same is true of dynamic proxies. So at build time, we pick up the list of proxies that we know we are going to use at runtime, because we know your application, we know how Hibernate works, how Reactive works. We can optimize this. And we also optimize static initializers because we know some frameworks need to be can be initialized at build time, and others need to have parts running initialized at runtime. So we can separate those things and make sure that we push as much as possible at build time, but some things like opening sockets, etc., all this, starting threads, all this needs to happen at runtime.
Yeah.
Now the question is, when do you use which VM with Quakus? What we advise is that, obviously, the easiest, if you want to use dev mode, etc., and you have all the tooling you have the debugger, you have the profilers, then you're going to do all your development on the JVM mode. So you're going to do all your development on the JVM, and this is, you already get a fast startup time, and you have, but you have, that's also where you get the best CPU performance, because the JIT can actually optimize your application better than native compilation. You also have the best garbage collector, but the downside is that you have the highest heap usage. On the other hand, if you run natively, then you get faster startup time, but you have a slightly worse GC and a slightly worse performance. So the question now becomes how exactly you deploy this. And very often people would tend to have long-running processes deployed of their application running on the JVM, because as soon as you send some traffic to them, then they get very optimized and they can run fast enough. And whenever you have some peak usage and you need to start scaling out, you can run them on native image because they will run faster, and it doesn't really matter if they're a bit slower than the JVM. You just start up much more of them, and then you scale them to 0. So that's one of the options. If you're doing serverless, probably you need the native one, because then that's the one that starts fastest and scales to 0. So the Quakus core, all the core extensions.
2 minutes.
All right. All the core extensions, we make sure that they're supported on GraalVM. So out of the box, everything you can use on Quakus will work on GraalVM. We make sure of that. And a question that is very often asked is, can I add my own dependencies, or do you need to use the Quakus extension that we wrote for that? You can add your own dependency. It will always work on the JVM. And it may or may not work on GraalVM, but you can try. And if it doesn't work on GraalVM, then you can write your own extension and start adding support for native compilation to it. And then take it from there and add more things like build time, startup, and memory improvement, and developer joy to it.
That's that.
There's that.
Thanks, everyone, for coming. Do you have any questions? No questions? I don't know if I'd actually be able to see if anyone had their hand up anyway.
Yeah. One question over there.
Só segundinho, vou levar o microfone.
Somebody is coming with the microphone.
Hello.
Oh, sorry.
I was just going to kick things off by asking, so what happens if I've got like a lot of unit tests, like 5 or 10 minutes worth? How is that going to help with continuous testing?
So you can include or exclude tests. So if you've got really slow ones, you could, say, add a tag to them and exclude that tag. If you've just got a really big test suite, continuous testing only runs the tests that are directly affected by your code change, which is really hard to show in a demo like this when you've only got 1 or 2 classes. But if you had 100 tests and like 1,000 different classes in your application, it won't run all the tests in every change. It actually tracks which tests affect which code using a technique similar to what code coverage tools do. And it uses that to figure out which tests need to be run every time. So even with large applications, it still gives you really fast feedback.
And that's really a killer feature. That's very important. There was a hand raised over there.
Hi. I didn't quite catch when when it's better to use the JVM versus the native VM?
So you're better off using JVM if you really want to run a Quarkx app using in sort of not much memory, or if it's going to be started up and stopped very frequently. So if it's like something like a function and it might be, it might only live for 10 seconds, then you're better off using native because it's got no warm-up time and it can run in a lot smaller memory. If you've got a large heap and it's going to be long-running, you're better off using the JVM. So if you've got something that has access to a gigabyte of heap and is going to be around all day, the JVM is going to give you much better performance. Is there any more? I can't really see.
No? All right. Well, then thank you for coming. And see you soon for the next. Okay, that was interesting. All right, thanks for coming. Oh.
Hello. Welcome. OK, so just before we start, I just want to know who attended the previous session about Quakus. All right, good. So I'm going to be a little bit fast on the beginning because you already saw that, and look a little bit more into details, into Kafka and things like this. So first, let me introduce myself. I'm Clément Escoffier. I'm working at Red Hat. I'm doing a lot of reactive stuff that include Quakus. And that's what we are going to see today, Quakus, and how we integrate with some part of the reactive landscape, which is all the messaging and reactive systems part. So the first thing is, who is less than 27 years old? A few, OK. So for those young people, 27 years ago, Java was created. And the world 27 years ago was very, very different from the world we have today. And where we were mostly developing with a complete different set of constraints. We were developing what we call monolith architecture. So what they are? Well, when you develop a monolith architecture, everything runs in the same process. That means that everything runs in the same memory space. The big advantage of this is that it's pretty fast because calling a component to another component doesn't cross the process boundary, so everything is fast. You never have data loss or message loss because it's inside the same process. The problem with monoliths, when they are not necessarily correctly done, or even when they are correctly done, is that to release them, you need to orchestrate many, many teams. Why? Because the code size of your application is generally more than just a few classes. And then in that case, you have several teams working all together. And in that case, you need to orchestrate all these people, all these teams, to get the release done in time. That orchestration takes time, takes energies, and yeah, it was always tricky. So the result of this is that when you build a monolith, you generally release it once a year, twice a year, but rarely more than this. The microservice approach that became popular a few years ago is trying to attack that problem by saying, well, let's split this business, your application, into a set of software islands, and everything will be fine because all these islands will evolve at their own pace, completely independently from the other island, and everything will be great. So if I want a new feature, I can develop it, and that's it. I can develop it, maintain it, operate it, retire it, without touching the other microservices managed by the other team. So on the paper, it's great. In the real life, it's not that great, because basically this independence is not true. As soon as you provide a service which is used by another service, if you change it, then you have a problem. So there is still this orchestration, but yes, technically speaking, we are a little bit more independent and we can build things a little bit faster. So this business agility, on one side, is great for business, but on the other side, it makes developers realize that distributed systems are hard. Because yes, when you start splitting your things into this software island, you are just building a distributed system. So there is no better definition of a distributed system as the one from Leslie Lamport from the MIT that says that a distributed system is doomed to fail. That's it. You can be brilliant, your distributed systems is going to fail at some point. Failures are part of any systems. So you need to, instead of trying to build a failure-free system that doesn't exist, you will need to embrace those failures, react to them gracefully. So microservices became very popular a few years ago, but if we follow these continuums, we start seeing serverless or function as a service. So in that case, you are not going to deploy island, you are going to deploy really small things, your function, and that's it. So what's the main difference is that in that case, in the function of the service world, by default, nothing runs. So all your resources are free, and so on. Well, nothing runs, that's not true. You have a proxy that is running, that waits for HTTP request, and once they receive the request, find the function, instantiate it, execute it, and kill the function. In that world, in addition to be a distributed systems, it stresses the need for having a very fast startup time. Why? Because if your function takes 1 minute to start for 1 second of execution, yeah, you see, you pay for 11 seconds. That doesn't work. So we need to have a fast startup time. So microservices and serverless have been successful these recent years because there are the combination of many new technical trends. Containers, Kubernetes, and things like that. So who is a Java developer here? Yeah, almost everyone. That's good. So when we take a Java application and we put it in a container, we got that. Yes, it's possible to put a Java application in a container. See? It's funny, right? But it's not necessarily useful and a little bit dangerous. Little bit. And the problem is that Java was designed 27 years ago when containers were not part of the picture at all. They were existing, they were created almost at the same time, but completely different landscape. So, and the problem is that when we build in containers, when we want to run something in the containers, we need to think that we are going to share resources. So, who is a parent here? Who has kids? Okay, so when you have kids and you try to teach them sharing, as you know, it's not that simple, right? Sharing is hard. That's exactly the same for Java developers. The problem is that for years, Java has not been designed for containers. So you can say, yes, but the JVM has evolved a lot, and now everything is fine. Yeah, sure, it was terrible a few years ago, and now it's good enough. But the problem is not only the JVM. The problem is also the whole ecosystem around Java that does not necessarily understand that you need to share the resources. So why sharing? Because containers are not really about isolating things. Containers are about sharing the same set of resources, CPU, memories, file system, and so on, across multiple applications. What you want to achieve with containers is deployment density, using your resources at best. That's what you want. But for this, you need to share the resources, and so you need to use them efficiently. You need to use them while thinking that, oh yeah, I cannot use everything for me because another application is going to use something else. So in the Java world, I say that it's not necessarily easy because for years, that kind of model was used. So a lot of threads to handle your requests. Each thread is 1 megabyte of memory, sometimes even more. It also costs CPU time because of the context switch you need. So it's 10 microseconds per context switch. And all this adds up, and at the end, you are using a lot of resources. So you can say, yeah, but I don't care. I use quotas, and everything will be fine. I can limit my applications to just use the things I believe is going to be used. So the problem is that as soon as you reach your quotas, the container host is going to kill you, period. So that's great. At least it will save the resources. So when you are facing such kind of things, you can do two things. You can think about maybe the execution model I was using was not necessarily great for containers, or you can increase the quotas, which we all did. It doesn't fix the problem, but we all did that. So that's what we had in mind when we were starting to build Quakus. So as it was said in the previous talk, Quakus is a stack to build Java applications that are truly cloud native. By this, I mean that any Quakus application will behave correctly in a container, will understand what being in Kubernetes means, will understand what it means to be orchestrated by an orchestrator, such as Kubernetes and others. It will use the resources efficiently and so on. So at the beginning, our main objective was microservices and serverless architectures because it comes with a lot of constraints. We saw them: startup time, distributed systems, and so on. But actually, it's not limited to that. We can do a lot more with Quakus. So, but when you think about it, what we achieved in the past few years is not just yet another Java stack, truly cloud native. What we build is a real good Java stack to build better distributed systems. So what does that mean? That means that when you think about that, you don't only need an HTTP server somewhere that exposes a REST API, which is sometimes just an HTTP API, absolutely not REST. You need a lot more than this. You need database access, you need clouds, you need workflow, you need messaging, and so on. And our goal is to provide a stack that lets you build better distributed systems. So today we are going to see all this: HTTP, cloud, Kafka, containers, but we are going also to look into 3 other red words: elasticity, resilience, and responsiveness. That's what define better. So what does that mean? Elasticity means that your system is going to auto-scale itself based on the load, always using the lowest possible resources. Resilience means that when failures happen, and they will, necessarily, it's a distributed system, they will happen, you will handle them gracefully. Responsive is the combination on both. If you can continue to handle the work, handle the load, even under fluctuating load, so elasticity, and even when facing failures, you become responsive. Responsive is what you're trying to achieve. That's what defines better. A better distributed system is a responsive distributed system. So Quakus is basically 2 main principles mixed in. I'm going to be a little bit fast on that because Stuart and Stefan already covered this. But basically, when you do a traditional Java application, you do build things, Maven package, Gradle build, whatever. You get a FATJAR, EIR file, whatever. And then you do java-jar, blah, blah, blah. Then, at runtime, it's going to locate some resources. Because the ecosystem still has a foot in the old world, there is a good chance that those resources are XML files. So to read XML files, you need an XML parser. Xerces? Anyone? Who loves Xerces? Oh, no one. That's weird, right? But the problem is that, yes, we still need Xerces to read those XML files, even if they're empty, even if they're meaningless. Then we need to do class path scanning, because in Java, we love annotations. But one of the problems with annotation is that to read them, to load them at runtime, we need to load the class. Every time we load the class, in addition to the dance of the class loader, we are going to store some metadata related to this class inside a part of the JVM, which is named the metaspace. And the metaspace is not garbage collected. So you are adding data and data and data, because we need to load all the classes from your class path. Yeah, sure, we can reduce the packages and things like that, but basically at the end, you still have loaded a lot of classes. Once you have done that, you have the meta model of your application, meaning that we know what needs to happen. And finally, we can start the pool, the threads, and so on. Quakus will do exactly the same thing, but before, at build time. At build time, we are going to load our wonderful XML file, maybe use Xerces. At build time, we will do the class path scanning and find all the annotations. So at build time, I know exactly how my application is structured and what need to run and so on. Which means that at build time, I know I can deduce exactly the set of instructions that are required to start my application. And that's what we inject inside our artifact here. What does that mean? That means that at runtime, I will start way, way, way more quickly. Not because we are smart, no. Just because we do a lot less Everything has been done before. So everything that is done before doesn't have to be redone here. And boom, we start fast because we do less. It has also a big interest in terms of memory usages, because all the classes that generally are loaded at that phase don't need to be loaded at that phase. The exercise things that we need there, we don't need it there. So because of this, we are going to reduce the memory consumption. A side effect of this build time principle is the ability to compile our Quakus application into a native executable, as you would do it with Go, Rust, C, C++, and so on. So instead of having bytecode, you are going to take the bytecode and compile it into native instruction directly. To do that, we need a compiler. And in the great families of compilers, you are only considered serious compiler if you have at least 5 or 6 arguments. Under that, you are not serious. So the compiler we use is named GraalVM. And believe me, they are very, 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 very serious. That means that beyond the hello world, it's humanly impossible to compile a Java application to native without any help. It's just too hard. Too many parameters, too many arguments, too many limitations. Quakus has, during the build time, during that phase, collected many data about your applications, and so can configure your GraalVM compiler to create an optimized native executable. Optimize is important here. We have seen competitors doing the same thing, but taking shortcuts, making compromises. We don't want to make compromise. We want to have the most optimized native images. Why? Because if you use native, it's for 2 reasons. Memory and startup time. If, by making compromises, you extend the memory usage to be the same as a JVM application, there is absolutely no point going to native. There is many limitations in native, and one of them, which generally Java developers understand, is that in Java, debugging is easy. In native, debugging is GDB. Who remember GDB? Yeah, it's great, right? Amazing experience, especially when you come from the Java landscape. So anyway, you should not consider that native is definitely what you need. It's a nice thing, but analyze before going there. So now I'm going to talk about the pink or red wheel here. So by default in Java, the imperative execution model is the following. You have an HTTP server, for example, you receive an HTTP request, and you are going to assign a thread from a worker pool to handle that thread. That thread is going to handle that request from the beginning to the end. Simple. What's interesting in this model is that the development model is very, very simple because things are executed sequentially. But we are building distributed systems. So there is a good chance that at some point, your request processing will need to interact with a database, another service, or something like this. And in that case, well, you will block, meaning that your thread is going to be blocked waiting for the result of that I/O. So if you want to handle a concurrent request at the same time, then there is no choice. You need a second thread, which will handle another request, and so on. So that means that the level of parallelism, of concurrency of your application is limited by the number of threads you have in the worker thread pool. But what we said at the beginning, threads are expensive. They are limiting your deployment density. They are not making your application very containers friendly. So that model is easy to work with, but not necessarily resource efficient. The competitive execution model is a reactive execution model. In that case, we are taking a completely different approaches where you have a very few threads that we will call I/O threads or event loops. For people that are doing Node.js, that's exactly this model. You will receive a request, start its processing, fine. But when you have to do an I/O, again, database, other service, and so on, instead of blocking, you are going to use the operating system mechanism to schedule that I/O and associate with that I/O a continuation. A continuation is a block of code that is going to be called when this I/O completes, successfully or not. So how it works. So we get the request 1, bam, we need to do I.O., we schedule the I.O., pass the continuations, the thread is released, so I can handle the request 2 with the same thread. Right? It's not a different thread, it's the same thread. Request 1 is still in progress, but I'm waiting for some results. When my event loop is idle and I get the continuation, the I.O. from the request 1 is arrived, then I will just call the continuation on the same thread, and so on. So this model scales a lot better, is a lot more resource efficient, but we need to use this I.O. scheduling and passing continuation. Passing continuation is not natural from a Java developer. You can use callbacks, but no one really wants to use callbacks. We can use reactive programming, you can use coroutine and things like that, but basically, at the end, it's always a little bit more complicated than the imperative execution model. What you need to understand is that the core of Quakus, everything is reactive. All your I.O.s are going to go through Netty and Vertex, which is a part of our reactive cores, and so you have I.O. threads, and then you have extension, and then you have your application code. Does that mean that you need to write application code using continuation and things like that? No, not at all, because basically, Quakus can detect if your endpoints are imperative or reactive. Depending on the signatures, on the set of annotations and heuristics, we can detect that at build time, and so we know if we need to switch to a worker thread or not. So what's the advantage of doing this? All the bottom of the stack till the routing layer is still executed on the I.O. thread, which means that you have a lot of advantages doing this. There is no thread pools, nothing, until you have to reach, until we call the function, and the function will be executed on a worker thread. When the function completes, then we will switch back to the I.O. thread and so on. However, if this is not enough for you, if you really want to go to reactive routes, no problem. Inside the same application, you can just have few reactive endpoints, the ones that are hammered a lot, for example, and then you just use the reactive programming model we provide in Quakus, so Mutiny or Kotlin coroutines, or you annotate your method with @non-blocking or something like that, and automatically Quakus will understand that these endpoints are reactive and we will stay on the I.O. thread. Max concurrency, best resource efficiency. Okay, so let's now talk about Kafka. So there is a bottle of rum here. Who is using Kafka? All right, I'm going to change your mind. Ready? Go. So Kafka is becoming very, very popular over the past few years because it's becoming the backbone of most modern systems. So the idea behind Kafka is to manipulate the data while the data is still in motion between the collection point and where it is stored, the data lake. And we will do processing and things like that. At the core of Kafka, there is a record. A record is a key-value pair, very simple. The key can be null, the value can be null, and the key and value can be null together, but there is absolutely no use case for that, but you can do it. Anyway, so on the producer side, you are going to create a producer record, which has a topic, a key, and some data. As I said, the key can be null, so you can have just a topic and some value. So here I'm just using strings, but obviously you can use any type of object, meaning that there is a serialization mechanism which is going to take your object and serialize that to bytes. On the consumer side, you get just a record with the type of the key, type of the value, and now we have, and you can get the key and value and so on, and manipulate that. It will be deserialized automatically. All right, so these records are returned to partitions. Partitions are log files, so append-only structures, which means it's pretty fast to write because we know exactly where we need to write. We will always write at the end of the file, so we can have a cursor and we know exactly where we are going to write. These partitions have numbers, so 0, 1, 2, 3, and so on. They will have records, which will have, they will be enumerated using an offset, 0, 1, 2, 3, and so on. And partitions are what are replicated, meaning that you can, if you have multiple brokers inside your Kafka systems, which is a good thing, to avoid data loss when one of the Kafka broker crashes, you want to replicate your partitions. So saying, yeah, this partition is going to be there, and a replicate is going to be on another broker, meaning that every time you write, there is a replication kicks in and so on. The notion of partition is key here, because that's also what limits your concurrency. We're going to see that. Your partitions are grouped into topics, and each topic can have one or multiple partitions. And as I said, it's what limits your concurrency. To write, no problem. Basically, when you write, Kafka will deduce on which partition it needs to be written. When you read, that's a little bit more complicated. You are going to poll the records, so it's not a push, it's a poll. And basically, consumers, so these things that poll, will be organized within consumer groups. Inside the consumer groups, basically application, each consumer instances that subscribe to a topic they will share the amount of partitions. So each partition is assigned to a single consumer per consumer group. So if you have two partitions, like in my coffee topics here, and you have one consumer, fine. This consumer will get the two partitions assigned to him, and he will just get all the records. If you have two consumers, okay, then each consumer will get one. Great. If I get three consumers, well, the two first consumers will get one each, and the third one can go in vacation, because he won't receive anything. That's how it works. So basically, the number of partitions is your max level of concurrency. So Kafka is simple. If you go to the website and you follow things and everything is fine. At the beginning, I say, hey, this thing is pretty cool. It's so simple. So you do a Kafka producer. Great. OK, it uses a config, which is a map string object. Why not? But yeah, OK, I can do that. And then to write, oh, so simple. You do producer.send, new producer record, topic, the key, the value. We're good. And to return the features, oh, that's asynchronous. That's cool. That's exactly what I want for my reactive things. Like, I want to build better distributed systems. That looks like a great thing. Except that when you click on this and you look behind the hood, that's what is happening. So the first thing is that the producer is going to wait for some metadata of the cluster in a blocking fashion, because he needs to know what are my topics, what are my partitions, and so on. Then he needs to serialize the keys and the values. And this is also a blocking mechanism, because it may need to call a schema registry or something like that. So it's going to do this. So you have the byte array for the key, value, and so on. And then it will call the partitioners to know on which partition I need to write. It can be on the partition 0, 1, 2, 3. This is also something that can be blocking, because the partitioner have access to the cluster API. And then something that a lot of people ignored is that the write is not immediate. Your writes are accumulated into a batch of topic partitions, and you have a second thread, an IO thread, which is going to poll those batches, which are complete, and do all the write and all the network things and so on. And it's when this write completes, then you get your record metadata. But all the first part of the process is completely blocking. Second part is not blocking. So it returns the features, but it's still blocking. You need to be aware of that. We were surprised by such kind of behavior. You can say, well, consuming is easy. Consuming is easy because if you follow the rules, you will do something like that. You have your map, you create a consumer, you subscribe to a topic, and then it's written like this. You do a while true, you poll, you max your poll to 1 second, or whatever time you want, which means that after 1 second, it will return the batch of records. You poll by batch, so you get a set of records every time, and then you process them. Processing records means writing to DB, writing to another Kafka topics, well, whatever you want. At some point, you need to inform Kafka that you processed all those previous records, so if you crash and you restart, you will restart from that position, so that offset, and not from the first offset. This poll method is actually very interesting, because when we look into that, it shows that we need to think about a lot more things, like, what about heartbeat? We'll see what it means. When do I commit? How do I commit? How do I handle failures and errors? As we said, distributed systems, we need to handle them gracefully. What about back pressure? If I get way too many records and I can't handle them anymore. What about rebalance, which is what is happening when I have a new consumer in my consumer group that arrives, or when one of the consumer disappears because it's dead or whatever. When we look at the poll method, is what is actually happening. Fetching the records is a blue box. Everything else is actually very, very important. So the first thing you will do is try to connect to the broker to find the coordinator of the group, which is one of the brokers which will coordinate the consumer from the consumer group. That broker will start with a consumer a heartbeat protocol, which means that if you don't call Paul again during that period that you defined, the coordinator will consider you dead, meaning that you will not get any more records. You can try to call Paul, won't work. You can try to commit, won't work, because you didn't call Paul enough. So once you do that, you join the groups, there is rebalance happening and so on, fine. You get the assignment, you reset the position, and you fetch the records, and finally you get the records. But the thing is, when we process the records, so we need to call Paul frequently enough to avoid being killed, but on my machine, it's very fine. If I get records, I write to a database, everything runs on my machine, everything's fine. I don't have latency between me and my database. But in prod, imagine that you are retrieving 500 records, which is a default, and you have a latency between you and your database. Well, you are going to block and wait, and boom, you forget to call Paul, and you're dead. The coordinator will just say, no, you didn't call Paul fast enough. Why? Because you were busy writing to your database. That's it. So you can say, yeah, let's switch to asynchronous so I don't have the problem. Oh, you do have another problem now. When do you commit? Because that's the whole thing. Commit management in Kafka. When you have your topics partition and you read it, you can say, OK, 0 and 1 has been processed successfully. But I have also pulled in my land badge the 2, 3, 4, 5, and 6. So for Kafka, you're here, but you only committed here. So the last committed offset, and that's something, is the last processed offset plus 1. You can be sure you will have a plus 1 wrong when you do Kafka at some point. It's weird. So that means that if I process asynchronously, and I got 3 and 4 processed, but not 2, I cannot commit 4. Because if I commit 4, it considers that 2 has been processed correctly, while it's still not the case. So we will need to track all this stuff. And believe me, to have done that code, it's complicated. So that's exactly what we try to do in Quakus, is hide all this complexity without limiting your flexibility. So for this, we're using a middleware which is named Reactive Messaging, which its goal is to build event-driven architectures. And at the core of event-driven architectures, you have the notion of event-driven microservices. An event-driven microservice is consuming events, messages, and producing events or messages. So how it works with that middleware in Quakus, so you have connectors that will connect to your messaging technologies, such as Kafka, RabbitMQ, whatever. And you have outbound connectors that will do exactly the same, but to write. Your application is structured among a set of beans, which will be event-driven beans. And these beans will receive the messages from channels, which are virtual addresses, produce events or messages to channels, which will be consumed by another beans, until the last channels is just pushed to the connector. So the notion of channels, which is these virtual addresses, is key, and just it's how things will communicate. So in terms of code, how does that look like? Well, if you want to read from orders and want to write to queue, you will write this. I want to read with @incoming from orders. I want to write to using @ongoing to queue, and I need to say to Quarkx, hey, this is a blocking process because processing an order to create a beverage takes time. We will see why in a few minutes. when the processing is done, the reactive messaging and the Quakus will implement an ACK chain, meaning that when you write the message to Kafka or to a database or whatever, we will acknowledge the message, which will acknowledge the message, and so on and so on and so on, until we reach the inbound connector, which will apply an ACK strategy. The ACK strategy is a CINI that will track your records and decide when and what it can commit. So how does that work? Well, it's exactly what I said before. That means that it will pull only if it will commit only if everything before has been processed successfully. So we will track, and as soon as we have a sequence of acknowledged and so processed correctly records, we can commit that position. We don't commit too often, because committing too often is introducing a lot of load on the Kafka broker. So we commit only every 5 seconds. But what about poison pill? So poison pill is a record that you can't process. That's it. It just crashes. Doesn't work. The problem is that with tracking our offset, if I have my offset 4, which is a poison pill, while it can be committed, that's what is weird, because 3 has been processed, 5 cannot be committed because 4 will never be acknowledged. So a poison pill. In that case, we need to have a mechanism that prevents you from that. Because basically what it means that your application can't make any progress. So if you continue pulling and pulling and pulling, what will happen is that you will just use all your memories. All your memory means also that the memory that you use that should have been used by the other application from the same host cannot be used, so it's pretty bad. So what we do in that case is that we detect such kind of things and I'll automatically mark your application on unhealthy if after 60 seconds your records has not been processed successfully. Of course, this timeout can be configured and so on. But changing this timeout is a very, very bad smell. So we also have negative acknowledgement when a failure happens. And when a failure happens, like this beans fails, then we will automatically knock the message, knock and so on, and then we have a knock strategy. But in Kafka, there is no knock. That doesn't mean anything. So we can fail fast, we stop. OK, fine. We can ignore the failures. Don't do this. But, well, we have it. Or we can write the records to a DLQ, meaning that you already plan that something or someone will read the DLQ later. The problem with DLQ in Kafka is that Kafka is very keen in keeping the orders. If you write to a DLQ, orders doesn't matter anymore. So it's not necessarily sure of what you want. So if you use Kafka, the only thing you can do is fail. That's the safest thing you can do. Of course, you can retry. You can retry, and for this, you will use a small y fault-tolerance annotations, like fallback, timeout, and circuit breakers, and so on. But only retry if you know what you are doing. You may break your system because you are creating duplicates. So, in general, do not retry without having checked that you can really retry and your whole system is idempotent, which is rarely the case. So how to retry? Well, you just add the @retry and you're done. That's the beauty of it. Most of the time, we need to bridge HTTP and messaging, and in that case, we will use what we call an emitter. So an emitter is just an object that we will use to emit things on the channels. Here, we are going to emit orders on the channel orders. Or I use it, orders.send. That's it. We have the same thing on the other side, but we're not going to cover that for time reason. So what about back pressure? It's one of the key aspects of better distributed systems. So reactive system is all things keep pace. So everything is, no part of the system is overflowed. So we are using Reactive Streams, which is one way to manage back pressure, not the only way, but it's one way. It's a non-blocking and asynchronous back pressure protocol. So what it is? Well, it's relatively simple as soon as you do data streaming. When you have a producer and a consumer, and producer send things, then everything is fine if the consumer can process these things at the same pace. So if everything is fine, everything is fine. If your consumer is fast enough, voila. However, if your processor starts to emit a lot more data, and your consumer can't consume, then you will need to buffer things. Buffering means using memory. Using memory is bad. We have seen that. That reduces your deployment density. So you should not do that. So what can we do? Well, we need to have signals that say that the consumer say, hey, come on, I can't handle more, so please stop. However, in Kafka, it's not that simple to do this. So what we are doing is basically your application, which limits your capacity because you write to a database or whatever, need to inform Kafka that it can't handle more. And for this, we're using pause and resume cycles. So basically, we tell to Kafka, oh yeah, I'm going to pause that subscription. We still need to call Paul periodically. We just say to Kafka, yes, I'm going to call Paul, or I will be dead, but don't send me any records back. I know, it's weird, but that's how Kafka was designed. When you still have the capacity, we will resume and get the things back, and everything is fine. So time for some code, because end of talking, and it's time to do some live demo. So we are going to use a reactive coffee shop demo that you can find at this URL over there. And basically, there is two types of coffee shops these days. There is the old-style coffee shops that you have here, where you go see the bartender, you ask for an espresso. The bartender goes to the coffee machines, prepares an espresso with love and time, because it takes time to do good coffee, and then brings that coffee back to you, you pay, and so on. Great, except that during that time, a couple of customers queued up behind me. Not really reactive. New type of coffee shops is where you go, you enter, you see someone, and you do your order, okay? They ask for your name, which is weird. They misspell it, writing it to a cup. You can't believe how many weird way Clement has been written in such kind of coffee shop. And it's kind of rude, but then they tell you, hey, go over there and wait. So you go over there and wait. So you wait, so you, as a consumer, is waiting. But the key thing is that they can handle other orders during that time. And they will write lots of cups with lots of misspelled names that they will add to a queue, and you have baristas that will just take that and prepare your beverage. Right? So we will see the two things. All right. Oops. So my coffee shop should be started already, like this. So I go there, I enter my name, and the first thing is that I'm going to take an espresso from a regular coffee shop, so HTTP, which is completely blocking, so during that time, nothing else can happen. So what will happen is that, yes, it's working, but I cannot order another thing. It takes time to get a good espresso, right? If my barista is down, then I cannot get espresso at all, and my orders are lost, which is sad, because I need a lot of espresso. So how is that done? So if we switch to the code, so this is a Quarkus application, which uses a few extensions. So this is to call my HTTP barista. This is to serve the coffee shop. And there is this one. This one is a Kafka connector for Quarkus, which will do everything we just said. So ACK, NACK, throttling, and so on, the back pressure. It also comes with a dev service, meaning that you don't need to have Kafka on your machines. As soon as you start an application using that connector on your machine, it will start Kafka automatically. It doesn't start any Kafka. It will start what we call, where is that? No, sorry. Here. It will start Red Panda, which is a C++ implementation of the Kafka protocol. We have also options to start Streams instead. The advantage of Red Panda is that it's pretty fast to start. It takes 1 second to start, while a regular Kafka takes around 10 seconds, even if we optimize it. So, all right, so I do this. Here. Fault tolerance, we are going to see that. So my coffee shop is implemented that way. I have my barista service. My barista service is a REST client, meaning that I don't want to have my code polluted with HTTP code and so on everywhere. So I model my HTTP interaction using an interface, which we call a REST client. OK. And again, because distributed systems are doomed to fail, I'm going to protect myself against timeout and call this fallback, which means that I won't get my beverage, but at least I get some feedback that, yes, sorry, your espresso is not going to be delivered. How to use this? Well, you just inject it, and, well, you get your order, you return the beverage, which is just by calling the remote client, and boom, you're done. So how we will do the same thing for the new type of coffee shops. So we are going to send 2 events, and for this, because I'm receiving an HTTP request, I need emitter. So I'm going to create a first emitters which will send orders on the orders channels, okay? And I need another one which will be on the queue channels. I will explain you why, which will be an emitter of beverage, and I will call that queue. So why do we have these 2 things? So orders is what is read by the baristas. The queue is this part here. So it's where you see where is your beverage. Because you can be sure that when you go in such kind of things, you order your beverage, and people that came after you get their beverage before you, right? And you don't understand why, because you were first. So that will give you some idea of where you are. OK, so I have my 2 emitters, and now I just need to send my messages to Kafka. So I will do the orders.send, orders.send, order, I'm done, and then queue.send, and now I need a beverage. I just said your orders is queued, and that's it. The first one send to the barista, the second one send to the dashboard that our beverage has been queued. So now with this, I can go back here, sorry. Yes, that's the local one. OK. I go in this new kind of coffee shops. I give my name. They misspell it. And I'm going to ask for latte. Lots of latte. So the thing is, I don't have a barista at that moment. But it's not a problem, because I've sent the records to Kafka, and Kafka has durability. So it's there, just that no one is processing them. So because we need to implement the other side. So let's do that. I'm actually going to start it. Oops, where it is. Yes. So I'm going to start this second application in dev mode, and it will automatically detect that I already have a Kafka broker started in the other one and will connect. Because if every microservices will start its own Kafka, that will be a little bit stupid. So if I do this, oops, sorry. Yep, here. I just need to do at incoming, orders, at ongoing, queue. It's a blocking process, beverage. Process, order. And here we just do return a method I've prepared, which is just prepare the thing. OK, all right. So now with this, where is my, yeah, here. It should start, does it? Yep, let me refresh. So, misspelled it. And now it decided that something was wrong. Let me check. Oh, yeah. Let me try it very quickly. So anyway, once you have this, you may wonder about the configuration. So the configuration is actually very, very simple. There is none. The only thing you said is if you want to map a specific channel to a topic, you have this. Everything else, serializer, deserializer, and so on, will be automatically deduced from your configuration at build time and discovered for you. So you don't have to configure anything. So does that work now? Yes. So we have Jacobs processing things. So of course here you don't really necessarily see the elasticity of things and so on. So just to finish it, I've also deployed my system into OpenShift here. Oh, so with this, with that resolution, it's going to be a little bit weird. Okay, so yeah. So what's important to see is that this is my coffee service, this is my barista service, and this is my Kafka barista. And here, I don't have any pods. I don't have any baristas at that moment. So if I go there and order things, like Frappuccino, because I take a lot of times, nothing will happen, because I don't have any baristas. But if I start kind of autoscaler and operators or something like that that will monitor how many records, how many orders do I have, then it will automatically create the baristas for me. And now, oops, yes, here, you can see, no, yes, no pod. Refresh. I've seen the order. So it's going to create the number of replicas. So here it's 3. Yes. You see that now we have 3 pods because you have seen that we have orders in the queue. And once all the beverage have been processed, it will kill these pods automatically. So that's great in the sense that it's really on-the-fly resources that you only instantiate when you need that. And so if I go back here, we had Freddy, Charlie, Freddy, and Amelia that processed me. So if I do another run, just to show you, we probably went back to 0, I order a lot, and we will see that it would create the consumers and process them. Why it's so slow? Yes, so it's starting them. It's what we see here. If we go back, yes, now we have Ava, Poppy, and Oliver, which will process my thing. So if we go back here, just to conclude, oops, slideshow. So the famous last word. So we have seen a little bit of Quakus today. We have seen this morning the CRUD and things like that. Here we have seen Kafka. It's a lot more than this. And if you're interested, you can stay in this room because we will see GitHub apps by Guillaume. We will see how to write an extensions and things like that. So there is a lot more than this. If you want to go further, I will recommend you 2 books. The first one is available for free on redhatdeveloper.com. It's Quarkus for Spring developers. If you are Spring developers, that will tell you what are the differences, what are the key things. And the second one, which is a complete shameless plug, which is Reactive Systems in Java, which will explain why we put Reactive at the core of Quarkus and how you build a better distributed system with Quarkus today. And that's it. Thank you. If you like what you have seen this morning or today, go to the github.com Quarkus.io Quakus and click on the star button. That's completely useless, but that makes us, the Quakus team, very, very happy. Thank you.
Hello, everyone. Today we will tell you the story of how we scaled the development of the Quakus project and how we automated most of our workflow with the GitHub app. We will also show you how you can develop your own GitHub apps to do the same on your project and have fun doing it. So we know you just had lunch, it's nap time, but please try to stay with us. We have some cool things to show, some cool demos. So yeah, stay with us. Today with me is Johan. Johan is the project lead of Hibernate Search. He's also a Quarkus committer. And I'm Guillaume Smet. I'm also a Quarkus committer working on Hibernate Validator. So we are old school, so you have our emails. And yeah, in advance, sorry for our strong American accent. I think, yeah. In English, there is a saying, it's death by 1,000 paper cuts. And it basically says that small pain points can add up and make your life miserable. And that pretty much describes the situation we were in with the Quarkus project. We have a very large project that moves very fast. And a lot of small tasks on the GitHub side were slowing us down. So a couple of examples here. The first one is the time we spent triaging the issues. So we have a constant flow of issues and pull requests. And for each issue, we need to find out which maintainer we need to poke so that he will have a look at the issue. It might sound like an easy task, but when you have a lot of components, a lot of different maintainers, and when you have a ton of issues coming, it takes a lot of time. Second one is about affecting milestones. When I was doing the releases of Quarkus, I always ended up with 200 issues and pull requests without a milestone affected. So they were closed, there was no milestone, and for each I needed to figure out, okay, when did it get merged? When, if in which release, in which branch, which issues were fixed by this pull request, and it took a lot of time. The fact that we have an heterogeneous team working on a lot of different projects makes it harder because processes are easy when you are working on only one project, but when you are working on 5, 10 of them, it's harder. And the last example I will take is how hard it was to find the cause of a failure when the CI failed. So you have to understand that our build is composed of 40 jobs, 40 different jobs. You have JVM test, you have the Maven test, you have the native test. Everything is parallelized, and you end up with a massive amount of logs. And when you have an error, you need to go to the log in GitHub. Then you end up with the log being truncated because it's too large. So you end up going to the raw log, then go at the bottom of the 100,000 lines, then find the error, then go back to find the details about the error. And this was taking a lot of time. You probably have these issues with your projects, but you don't really notice it because the project might be small or it might be a bit slower. When you have a project at scale, the issue becomes very pregnant and you need to solve it. And you need to solve it fast because it's slowing down your progress. That's when we started to think about automating things. And the first thing we did was to create a Github Bot, a GitHub app, using the Probot framework. So Probot is a framework from GitHub. It allows to develop GitHub apps in TypeScript or JavaScript. We did a first experiment here, mostly with the triaging feature. And given it gave very good results, we started to switch to Quarkus and say, OK, what would it take to have this bot run in Quarkus? And we went way beyond with a ton of other features to solve all the problems I presented before, and a lot more. So the first feature we added is the automated triaging. So every time a GitHub issue is coming, every time a pull request is coming, we are testing the title, the body, looking for keywords, and depending on that, we are pinging the appropriate persons, and we are also adding labels. This is all done with a large config file saying, OK, if you have this regex matched, then you will ping this person, and then add these labels. The second one is how we automated our workflow. So every time you merge a pull request in the main branch, it will look at the milestone, find the one with the main in the name, and affect it to the pull request. It will also find out about which issues the pull requests were fixing, and it will do the same for the issues. So basically, you never have to affect a milestone yourself manually. And the last large piece we developed is an automated build report. So whenever a build fails, it goes through all the Surefire reports, and it builds a view of the status of your build. So you have the failing jobs, you have the failing modules in the job, you also have a description of the failing test. You can have the stack trace, you can go to the source, you can have a lot more details. Everything is centralized, and this way you can decide if it's just a flaky test, if it's my changes who somehow broke the build, and it saves us a lot of time. One more feature about that is that with GitHub, you can add annotations. So you have the ability to say, OK, the error is about this line failing, and this is the detail of the error. So we directly have the stack trace here with the failing line. So you can find out about your errors very quickly. And typically, this build, we started this build report thing, we started it in the core Quakus project. And at some point, it was so useful that we decided to generalize it to the other projects. And when it's broken somehow, for some reason, sometimes GitHub is not sending the payload or things like that, and he will send them later, we are missing it. So really, I think you can all see the benefits of having some GitHub apps to help with your workflow. And this is just an example of what you can do. And if you want your own, it's very easy, and Johan will show you how you can do that.
Right. When Guillaume started the work on this bot, he actually worked on an extension, which we expanded on later. So it was a Quarkx extension. The extensions give you the power of Quakus and allow you to develop features around it. In this case, the feature is the ability to develop GitHub apps in Java, in particular with zero boilerplate. Thanks to Quakus and its bytecode generation, we can spare you all the code, the unnecessary code. Of course, since it's Quakus, it gives you additional advantages like easy native compilation with GraalVM, which can be easy when you want to just start your bot fast. It's not a prototype. It's, like Guillaume said, it's been used in production for the Quakus project for 1.5 years, but also in other projects. The Harmony team uses a bot based on this technology as well, and other projects do. It supports GitHub Enterprise if you need that. But most importantly, it's a Quakus extension. So it's a library that you can reuse in your own bot. It's not a bot, it's a library. And that means you can be creative. You can create your own bot based on that library. So what should we do with our bot? Well, Richard here wants to basically close every bug report related to OSGI because he doesn't like OSGI, basically. So I won't agree with him, but I will try to help him regardless. So let's start with the demo. I have a blank page here, I will just try to create a new project. So I'll use the Quakus CLI, which was installed using SDKman. Quakus create app. Then I give the group ID of my app, the artifact ID, and I specify which extensions I want to use. Of course, I want the GitHub app extension. And I'll use another extension for GitHub apps that Guillaume will present to you later. And here we go. We have a GitHub app. The CLI just created a skeleton of an app with a POM file and a README, some Docker configuration. So I can start with that. I can start coding, but first, since I want my GitHub app to respond to events from GitHub, I need to tell GitHub to send the events to my app. So in this demo, we'll be using a small project, a playground project on GitHub, where we can create issues. And I already registered my app on GitHub and installed it on my repository. Here, the configuration is basically just giving GitHub an endpoint to call for each event and giving permissions to my app so that it can react on my project, like creating comments and issues and so on. Since we're developing locally, we have a firewall between GitHub and us. So we're using a proxying service, sme.io, which all the events from GitHub will be going to sme.io, and our GitHub extension will do the necessary work of fetching the events from sme.io. Of course, that's not something you would do in production, but it's very useful when you are developing. So once we configured that, we need to give our implementation some information so that it knows where our GitHub app, what our GitHub app registration is. So we will give it an ID, a name. We'll give the webhook proxy URL from sme.io so that it can fetch the events. And there are a few secrets to access the app using GitHub API, the repository. So once this is done, we will just copy, when we have this information, we will copy it to our project. I won't show you the content because it's secret, super secret. And we can start coding our app. So when we create a new class, oh, yeah, I create a package because I'm clean. I put my class here. The endpoint of my GitHub app will actually be simply a method. So on issue opened, I will receive a GitHub event payload, which is specific to, to issues. So that type is from the Hub4j GitHub API, which the extension imports, and the same library offers plenty of types to represent everything you can find on, well, most of the things you can find on GitHub. Once I have that method, I still need to tell the extension that I want it to be called when an issue is opened, and this is done through an annotation, simply. There are, of course, plenty of other annotations, which we can find here, well, which we could find if IDEA wanted to stop. You'll have to believe me. Yeah. OK, so we won't see it. There are annotations for issues, for pull requests, for lots of things, and all the lifecycle events you could have on those GitHub objects. Now, I will fetch the issue from the payload. And I will choose a keyword that I will allow me to recognize OSGI related issues. And if my issue title, ignoring case, contains the keyword, or if the body contains the keyword, then I will add a comment on the issue saying we don't support OSGI at the moment. We're going to try to be nice, at least. That's the least we can do. And we'll close the issue. That's it. Now, we will start our app. I need to go to the project, and I will start the Quakus dev mode. When we do that, the extension will connect to sme.io so that it can fetch automatically the events sent by GitHub. Now, if I go back to my playground project, I start creating an issue. I open my issue. Oh, shit. Sorry. And it's automatically closed by my, my app, which is running on my laptop right now. So with these few lines of code, I was able to, well, these badly formatted lines of code, I was able to create a bot in a few minutes, and this can be deployed right now. So to expand on that, I might want to add some configuration to it. So here, I might want to add, for example, a configuration file in my GitHub repository here to expand on other technologies that I don't want to support, like Cobra, for example, because I don't want to deal with that. And this is easily done by adding another parameter to my endpoint. So the thing is, I will need to represent the configuration file in my app. So I will create a Java class. In that class, I will have a list of keywords. So just a list of strings. Here. Now that I have this type, I can register. I can represent my configuration file here. And instead of hard coding my keyword, I will just iterate on all the keywords I have here in this configuration file. So what will be happening at runtime is that the Quakus extension will just fetch automatically the file from GitHub, and it will deserialize it and pass it to your endpoint. So I will save my app, and then I will try to create another issue, like and after a few seconds, my GitHub app will respond. So that was just as easy. So to conclude, you get a Quarkx application with all the developer joy that Quarkx can provide. I don't know if you noticed, but I did not restart my application after adding my configuration file. That's because Quarkx detects code changes and will automatically reload the parts of your app that are needed. You also get all the standards features you want. So if in your GitHub app you want to use CDI, you want to use persistence through JPA or MongoDB, if you want to use Kafka, you can do that. You get GitHub with the extensive Hub4j and GitHub API. You can do pretty much anything you want using the GitHub APIs. And you get more than that with the event annotations. You don't have to care about the boilerplate of detecting the type of event and routing it to the right method. You just put an annotation where you want. You have a replay UI, which I didn't show you, but here you can I can show you quickly. There's another endpoint on the dev UI in your application where you can list all the events your app received. You can view the payload, you can copy the payload, and you can replay the payload in case you change something in your app and you want to try again, which happens a lot in development mode. So, and there's also a Mockito-based test framework that you could use. I won't have time to show it now, unfortunately. But you get all that. You get Quarkx, GitHub, and more, and you actually get even more than that.
So the most recent feature we added is something pretty common in the GitHub app world. Typically, if you take the Dependa bot, you can control Dependa bot with a set of commands. You can tell it to rebase with Dependa bot rebase, or merge a pull request with Dependa bot merged. And so this looks pretty simple because, and you can do all that with what Yuan showed you before. But it's not as simple as it looks because you need to parse, to route your commands. You need to provide feedback to the user. If the command was not understood by the bot, you need to say, oh, I didn't understand what you were asking. And that's what we are trying to do with the command line extension. And we want to do it with annotations and with zero boilerplate. So let's see how it's done. So the first thing is that I'm the last Eclipse user, so I will import the project in Eclipse, maybe close this thing. And OK, let's find the right one. OK. So here we go, importing the project. So I will just create an additional class. And the fact is that you can mix both. You can have the approach Johan presented and what I'm presenting in the same bot. So the first thing is to create a class. We will name it bot. And we are using the airline extension, which is designed to parse command lines, to do exactly the same, but for command-based commands. So we will have a CLI, we will name it, and this is what will trigger the bot. So we will name it bot, and let's add a nice description. So Jnation bot. OK. And then the only requirement is that all the commands of a given bot needs to implement the same interface. And this interface needs to have a run method that will be used to route the command you are passing. So let's create an interface. We can call it commands. And we will have run method. And the method will take a payload, so exactly the same payload that Johan showed you before, but with an issue command. And yeah, that's pretty much it. Most of the GitHub APIs throw the EO exception. It's not pretty. It will be changed later. But the framework is handling it for you, so you don't really care about it. The next step is that we want to create an actual command. So we have the command extension for that, the command annotation, sorry. And you define a name. Let's say hello, a description. So the description is optional, but it will be used to generate the help. And then we will create a class that we will call say hello. It will implement the command interface. And OK, so I need to implement the method, actually. And so the method will do something simple. It will just take the command, get the issue, and add a command to the issue saying hello. And we will also provide some arguments to the command. So we can do that with a underline extension. It will be a list of string with names. And we will just join the names. And that's it. You have your bot done. The last thing you need to do is to actually list a command here. So it will be, say, hello class. You have to do that because you can also do a lot of things like grouping commands. Like typically what you have with Git, you have git remote show, git remote list, and you can do the exact same with this feature. So now, let's go back to our browser and the project, the issue Johan created, and let's say add bot say. So this is not the command we created, so let's see how it's react. And hopefully it will. Or not. Oh, it's not happy about something. Oh, yes, obviously I forgot what I didn't want to forget. So this nested class needs to be static. And that's pretty much it. Let's go back there, do the exact same thing. So the nice thing is that you have nice error messages, and you also can reload even if you do an error. So the bot didn't understand the command because it's not the one I defined. So it says it with a confused emoji, and then it will print the help saying, OK, this is what is supported. And that's why I added descriptions. So now let's get the bot to say hello to you. And let's see how it goes. So the command was understood. It launched the command, then it acted, and the bot is replying to you. So obviously, this is very simple and pretty stupid. But fact is that with just 10 minutes, you can have something working, and you can implement commands very easily. So we see that we are using annotations from the airline library to do the parsing, the routing, and most of the heavy lifting. We support permissions, so you can say, this command is only available for admin, this command is only available for this team, and you can define permission on each command separately. You can reduce the scope. By default, it will react to commands in issues and also in pull requests. But if you want to only react to issues or pull requests, you can do it. It generates some help. You have seen how it can do it. You can tweak it, add some more information. And it has a ton more options to fine-tune the behavior of the bot.
So to conclude, in the automation versus paper cuts battle, these small paper cuts, they add up. With the large enough projects, even the smallest inconveniences will become major inconveniences just because of the amount of them. The automation helps with that. It allows you to streamline your work by automating, by having some of these annoying tasks executed by a machine. And Quarkx GitHub app the Quarkx GitHub app extension can help with that by easily and quickly allowing you to create a bot that addresses these problems. And that with low overhead, which means that because of this no boilerplate approach, and you can smart a small application, even if for a small use case, put it in production, and then iterate from there. You don't have to wait to have tons of problems on your hand before you start. So it's made easy, and that's what Quakus is all about. It's an amazing platform to develop extensions which have lots of power, can generate bytecode easily and at real time. And those custom extensions are powerful, and that's what brings developer joy by moving stuff out of your plate, basically. So, thank you for listening. And here's a little example of what you should not end up with. Any questions? Right.
Hello. Is there any path to move to a different code repository other than GitHub, like internal repositories from organizations?
So it's really based on the GitHub infrastructure, the GitHub event payload, the GitHub API. Typically, we don't support GitLab, for instance, at the moment. We might at some point, but it would be nearly a completely different project because the infrastructure of the API is different and the way it works is different. So for now, it's really about listening to GitHub events and reacting to it.
On GitHub.
On GitHub.
OK, thank you.
Now that you have this automation in place, how you deploy it, for example? Or do you have support for serverless or something?
You can deploy it any way you would deploy a normal Quakus application. It's just an application which exposes an endpoint which Quakus will call. So you can create containers. There are Docker files included with every skeleton of applications. And you can deploy those containers on OpenShift. I think that's what you did.
That's what we are doing.
That's what we're doing for Quakus. For Hibernate, we have our particular infrastructure. So we create a container image on each commit to the main branch. We push it to quay.io. And we have a service installed on our CI machine, which automatically reloads the app each time a new container image is loaded. And we just run Docker locally on our CI.
And all that works in native. Yeah. So in native, that's basically that's what we are doing for Quarkus. We are building a native application and pushing it to OpenShift. We are not using serverless, but you could. The Quarkus bot is starting in tens of milliseconds, 20 milliseconds, something like that. So you could perfectly use it in a serverless world.
Thanks. So if you don't have your own infrastructure, can you run it as like a GitHub action?
So no, you can't at the moment. I'm working on a GitHub action thing that would be based on Quarkus. The idea is to simplify all the GitHub action heavy lifting, injecting the payload, injecting the inputs, providing outputs, things like that with an API that is Quarkus-based. So this is still a work in progress. The code is mostly done, but I haven't tested it with a proper GitHub action. And the plan is to use this thing with GitHub action to provide the same reports we are providing with GitHub app to GitHub action. So you could have a build and at the end call this GitHub action, and this GitHub action will analyze your Sapphire reports and post the reports to the CI build. And that's something that will land this year, that's for sure, and I don't know when. So that's what you can do with extensions. And if you are curious about how you can develop Quarkus extensions, there's a nice talk by Giorgio Senoli later this afternoon. And you should attend it if you are interested on how you can develop your own Quarkus extensions. OK, that's all. Thank you.
Thank you.
Fine. So, hello everyone. Welcome to the next talk. Our topic is efficient communication with Quakus and Grpc. My name is Martin Koba, and I work as a software engineer at Red Hat. I'm a member of the Quakus core team, and also contribute to the Grpc extension. And this is my colleague, Michal Sienkiewicz.
Yeah, I'm Michal, and basically all the stuff Martin said about him is also true about me. So I also work at Red Hat, also work on Grpc, and I'm also in the Quarkx team. So,
okay, thanks, Michal. Okay, so the too long, didn't read version of this presentation would be probably something like Quakus Grpc integration is awesome, but we're going to show you a little bit more. So this is agenda for today. We're not going to cover the Quakus basics because we believe that you already attended some of the Quakus sessions today. We would like to give you a high-level introduction to Grpc. Then we would like to discuss the user experience enhancements we did in Quakus, means what we have in Quakus Grpc integration. We also have a long and nice demo, so hopefully everything will work. And finally, if there are any questions, we can try to answer. Or after the talk, we will be, or at least me, at the Red Hat booth. So if you have any questions, feel free to reach out. Okay, so what is Grpc? This sentence is actually borrowed from the Grpc homepage. And they say that it's a high-performance, open-source, universal RPC framework. So let's do a simple analysis of this sentence. High-performance. So this is kind of obvious because nobody would be interested in low-performance framework, right? So you don't need to tell more about this. It's an open source. There was a project called Stubby, initially created by Google, and they decided to open source this project in 2015, so Grpc was born. And since then, it's an open source, so anybody can contribute to this project. RPC stands for Remote Procedure Call. It's a well-known communication technique used in distributed systems. Traditionally, it's perceived as some system where you send requests and receive responses. And the way it works is that in your code, you have some kind of local invocation of a function method, depends on your language. And this local invocation is transparently translated to a remote call. In case of Grpc, we also streams of messages are supported. And finally, it's universal, which basically means that it's a general purpose technology. You can use it to connect to microservices or mobile apps or even monoliths, whatever you want. It's also a cloud-native computing foundation incubating project. CNCF is actually a Linux Foundation project or hub, which aims to propagate cloud-native technologies. And the fact that Grpc is incubating means that it's basically on its way to become, now I don't remember the word they use for a stable project. So it's used in production, but it will still take some time to become a stable project. Like I said, it's open source. The official Java library is licensed under Apache license too. And it's hosted on GitHub, so you can file issues, send PRs if you want to. Now, this is really interesting and important. Grpc is a contract-first technology, which basically means that before you start writing your services and consume them, you need to define the contract. And in the case of Grpc, you're using protocol buffers language to define your services and the message payloads and so on. So when you have your contract ready, then you can start working with this contract in your favorite language. And the good news is that gRPC supports many languages and platforms out of the box. So it includes Java, Go, Python, Node.js, and even PHP. And the way it works is that you take your contract, which is protofile. Protofile means the descriptor file, basically. You take this file and then generate some code for your target platform. So in our case, it will be Java. And once you have the code generated, you can start using this code in your application. The generated code actually includes something they call stubs. Stubs are basically incomplete service definitions. So it's up to you to write the business logic, but the structure is defined. And the generated code also includes some kind of utils. They call it message builders, and they help you to parse and build the messages, which are actually payloads of your service calls. The messages are serialized using the binary format, which is again defined by the protocol buffers. And the result is that you cannot easily read the payload of your messages when they are sent over the network, because it's not a human-readable format compared to JSON or XML, for example. On the other hand, the binary format is much more efficient compared to human-readable alternatives. gRPC also runs on top of HTTP 2 by default. So this is nice because it's a nice new technology and so on. But on the other hand, you cannot use the tools you're used to develop your application. Because, for example, a web browser doesn't understand HTTP 2 enough so that it will be able to communicate with the gRPC service. And so HTTP 2 and the binary format of your messages, these drawbacks we actually try to address in our Quakus gRPC integration to make your life easier. Now, programming API. So gRPC has both synchronous and asynchronous API. It supports unary requests where this is just a fancy name for the typical request response style of communication. And also streaming, which is much more interesting. It supports client-side streams, server-side, and even bidirectional streams, which means that you have two independent streams in one service call, one for client and one for server. And finally, you can also use some metadata that you can attach to your requests and responses. OK, so that's all about the gRPC basics. And that's it. Now we would like to discuss what we did in Quakus integration to make your life easier. And the first thing, like I said before, you need to generate some code, some Java code from your protofiles, from your contract first. So we try to make your life easier a little bit in a way that the code generation is a little bit easier in Quakus. So first of all, you don't need to configure any build plugin, because typically you would have to add some Maven or Gradle plugin to generate your stubs. And we don't need this because there is already a Quakus plugin which can handle this for you. It's also integrated with the development mode, so that if you change your protofile, your contract, the classes are automatically regenerated. The only thing you need to do is change your application classes. And finally, we also added a thin layer on top of the generated stubs, which is a Mutiny-based API. And they could be used for both the client and the server. Maybe you should spend some time with Mutiny. Mutiny is a reactive programming library. It's an open source project. Basically, it is an idiomatic way of writing reactive APIs and consuming reactive APIs for Quakus. And it defines two reactive types, uni and multi. So whenever you see uni or multi in your code or somewhere else, you can be sure that it's mutiny and you will have some reactive fun. So at this point,
I think we have some understanding of what Grpc is, and what we wanted to do now is to show you how to work with Grpc and Quarkus. So if we have a lot of luck and with a bit of cheating, we may end up playing a little quiz at the end of this presentation. So let me start by creating a Quarkus application. So there's a few ways in which one could create a Quarkus application. For example, you can go to Quarkus.io and generate an application. But the way that I like the most recently is using Quarkus CLI. It even has some code completion. So with that, I can do Quarkus create app and select the Grpc extension. I will also use Reactive extension for one tiny little thing that I will show you in a minute. And let me call my project quiz server. I will open it in IntelliJ and show you what I got here. So in Quarkus, when you generate a project, we want you to quickly start working with it. So because of that, we generate some code that will show you how to work with the technologies that you have selected. So I selected Reactive, that's why I have some greeting resource and tests for that. So I remove that, I don't need it. But I also got an example protofile. So this protocol buffers definition for Grpc contract, a service for that, and a test for that. Actually, maybe I'll just start my server now and start working with it. OK. So it's starting, still starting. Almost there. Yeah, it should be there. So now, when I forgot about one thing. I wanted to add some dependencies first. That will help me later. So quiz, test dependencies, and maybe also the dependency for OpenShift, Quarkus, OpenShift. This will be so that you can all play the quiz later on. So I just added asset.j and our utility, nothing fancy. The main thing for today's presentation is Quarkus Grpc. As Martin said, we don't have any additional plugins for protocol buffers. We just have this generate code go in the Quarkus Maven plugin that will handle generating code from the protofile. So with that, when I started the project, under generated sources here, I have Grpc directory, and here is the stuff generated from the example protofile. So I'll add another protofile, but maybe first reload the Maven configuration and maybe switch to the presentation mode. By the way, are the letters big enough? Great. So let me add a quiz proto. OK. When I add something in this src main proto directory and it has a proto suffix, the code generator from Quarkus will figure out that there's something new there, and it will start compiling this file, and also on the changes of this file. Anyway, so first let's start with some header. So protofile, there are a few versions of protocol buffer syntax. The newest one is 3, but the default one is 2. That's why I'm adding the first line. Then I also have a Java package definition. If I omitted that, my classes will land in the default package. I don't want that. And I also have this Java multiple files thingy that makes the output of the generator a bit nicer, because otherwise all the generated classes would end up in one big class. And it will be inner classes, so it's not very nice. Anyway, let's start working on the quiz. So what do we need for a quiz? We need a way of getting the questions. So I cheated a bit, as you have seen. I used live templates to get the service. So this is how a service definition in proto file looks like. So I have a service called quiz. It has a single method called getQuestions. It is a RPC for gRPC. Accepts an empty input and returns a stream of questions. So a question has some text and possible answers, obviously. So let's implement it. OK. So let's call the implementation a quiz service. And so to implement a service in gRPC service in Quakus, it's enough to just create a class and annotate it with a gRPC service annotation, and then implement something that got generated from the proto file. So I have a service called quiz here. So what we generate is an interface called quiz. So yeah. So that's
we should say that this one is the Mutiny API.
Yeah, this is the idiomatic way to do it, but there are a few other ways as well. OK, IntelliJ, as always, is slow in picking up the generated sources. OK, it's there. So I have this quiz, and now I implement the quiz. I have to implement the method that comes with it. So there's the getQuestions method. That will return a stream of questions. So as Martin said, we are using Mutiny here. So the thing that represents a stream in Mutiny is called multi. So we are returning a multi of questions, so stream of questions, and accepting an empty request. So what I'd like to do is to broadcast all the questions to all the connected users. So the easiest way to do it in Mutiny is to use a broadcast processor. So let's do that. Let's call it question broadcast, maybe. OK. Now, I can just return it here, but I have to feed it somehow. So I will cheat with that a lot. I'll just create an admin package here. I need a way to trigger the quiz, so I'll just do it with REST-easy reactive. So let me call it maybe start resource. And quiz start resource. And what I also need is a riddle, which will contain the question and the possible answers and the correct answer. So quiz riddle. So as you can see, there is text of the riddle, the proper answer, and all the options for the answers. And I will also cheat on the riddle storage, from which we'll get the riddles. So riddle storage. I will try to cheat less later. OK. So here we have just a list of riddles. And when this bean, because this is actually a CDI bean, is created, I just add some riddles to this list. And then I have a method that gets a riddle by the index in the list. And if the index is too large, I will return a null. So here. OK. So with that, I'm nearly done with feeding the questions. So as you can see, this start resource has a single method that is start quiz, and it gets a riddle from the riddle storage. And if the riddle is null, it will call some end quiz method that I will code in a minute. Actually, a bit faster probably. And then there's also a broadcast question method, broadcast question method in the quiz service that will broadcast the riddle, but also a schedule sending out the next riddle after I configure delay, which is by default 2 seconds. So let me add it as well. So broadcasting is easy. I'll just do question broadcast on next. And riddle has a 2-question method. That's another cheat. So I already have the code to translate the riddle to the question, so extract the text of the riddle and answers and put it in a gRPC object. gRPC uses, or actually protocol buffers uses builders. So yeah, it's a bit more code than you would actually expect probably. But still, I think, quite self-explanatory. So on the end of the quiz, I will broadcast a fake question, maybe, with the text like, that's all, thanks for playing. OK. Oops, what did I do wrong? Okay, so with that, okay, I have a typo here, I'll fix it. But with that, I should be able to actually test it if it works. So let me switch maybe here. There are a few ways that I can interact with a gRPC service. One of them is gRPC curl. So when a gRPC service exposes something called reflection, gRPC reflection, that is, then gRPC curl can interact with it. So yeah, how the command works is as follows. So the default way for gRPC curl is using HTTPS. I haven't configured any certificates, so I'm in the plain text zone. And then I just specify the address of my service. It is localhost 9000. And I can, for example, list services, if it works. Yeah. So I have the quiz service, the hello gRPC service from the cold start, and the health service for the health of my application. So I can actually call my getQuestions method. So I think it was quiz getQuestions. And after that, I should start the quiz, because now I'm connected to the stream of questions, but I haven't started the quiz yet. So if I do localhost 8080/admin/start, I begin to get questions. So we have getting questions. The next thing, I think, should be probably answering the questions. So let me switch to that. OK, so again, cheating. Answer. So I will add a single method. This will be the unary request response. When an answer will come in the request, and some result will be returned. And so here you can see the answer is simple. It has 3 fields, some text of the answer, user that posted the answer, and the question. By the way, have you noticed this strange numbers here? These are IDs of fields in the protocol buffer message. These allow forward and backward compatibility. So if you have a client that doesn't know, for example, the user field, the client still can get this such message and parse it to their version of the answer object message. And here we have a result. So the result is just a status. So protocol buffers also support enums, and here we have an enum. So the valid options for this enum are wrong, correct, duplicate answer if someone tries to answer for the second time, and a timeout if the question is not the current question anymore. So I'll try to quickly code it and show you another way of interacting with gRPC applications if you do it with Quakus. So I should have the code generated in a minute. I mean, the code is already generated, just IntelliJ doesn't see it. OK. Let me maybe refresh the generated sources directory. OK, it worked. So what I want to do is I want to have some respond method. Maybe not to, for the presentation, not to be that boring, I will cheat again with that. So yeah, OK. I'll go through this code in a second. But first, to validate the answer, I need to have the current riddle stored somewhere. So I'll add it to the broadcast question. And so I need some storage for that. Riddle, current riddle. And just like when a question is sent, I will send the current riddle. Riddle. And when the quiz is ended, I will set it to null. So null, OK. So Now, let's get to this piece of code for a moment. So the answer comes if the riddle is null, so there is no riddle yet, or the last riddle, like the quiz was finished, or if the text of the riddle, so the question basically, is different than the question that the user is answered for, then we have a timeout. If the answer is different than the expected answer of the riddle, then we have a wrong response. Otherwise, we have a correct response. And yeah, we are in the reactive world here, so we have to use this mutiny return types here. So we don't return simply the result class, but we return a reunion of result class. So normally it would allow us to, for example, do some database stuff in the meantime, and then actually feed the uni at the end of this database job. But here it just means some additional code in the method. So with that, I think I can already try this. And by the way, I'll also show you how to connect to a gRPC service. So let me create a quiz service test. So it will be a normal Quarkx test. And I'll add a method called should validate answer, maybe. Answer. And just annotate it with the Jnation22 test annotation. So normally, for example, if I expose the REST endpoint, I would use rest assured to test it. There is no rest assured for gRPC, as far as I know. So to ease it as much as we can, we allow users to inject a gRPC client and pre-configure it to talk to their services if they're in the test. So, okay, to create a test, to create a client in Quarkx, you have to create a field annotated with gRPC client, and then you can use, for example, the same interface that we used to expose a service for the type of the client. So let's call the quiz client. And that's basically it, right? Normally, if you used it in the application, you'd have to add some properties that would say our service is there and there. But if we are testing our application, it's not required. It's configured automatically. So I'll just quickly try to write some test that makes a little sense. So first, I'd like to get the questions. So again, I have to store them somehow. So let me do atomic reference of question, maybe. So question. And then I subscribe to this result because this is all async, non-blocking, and so on. So I do question set when a question arrives through the stream. I have to pass this empty argument here. What is wrong here? Oh, sorry. Subscribe with. OK. So now I will get a question at some point. And what I also have to do is start the quiz, right? So it will be a bit ugly, but I'll just inject the start resource here. So start resource.
This is probably something you should never do, like injecting JAX-REST results in your test, but we are cheating a little bit because in Quakus, the resources are also beans, so we can do this, although it's not nice.
Not recommended. So now I can wait until the question is there. And so let's say at most 5 seconds. And until question is there. So question get is not null. So when I will have this question, I can create an answer for it. So this is how you create a protocol buffer object. Again, a builder. I think I showed you this already. So builder, we are setting the question that we got from the quiz, and then some text of the answer this text is set because I know what the question is. So the question is how much is 2 plus 3, so I can blindly set the 5 as the answer at the user's Michał. So now it should be enough to actually pose the question. So answer. And here I'm in the test, so I don't care, so I just kind of wait for, let's say, 5 seconds until the answer result comes, and I will do assert that result status. Oops, not this one. Status is equal to result status. Sorry, result status. Correct. Okay, and this has a chance of working. I will actually try it, but will probably fail. Okay. Yes, it failed. It failed because we are in a non-blocking world, so actually this get questions got invoked later than the start quiz. So what I need to do, and what I'd actually also like to do for the real application, is because we are in a situation where a user joined the quiz, but some question was already broadcasted, so they didn't get the question. So we wouldn't want that, so let's fix it. So instead of using a simple broadcast processor, we can use a multi of question here. Maybe I'll cheat with it, because I think I have it already somewhere. Yeah, this is it. So instead of using the broadcast processor, the simple way of broadcasting questions, I'm using a multi that replaces the last broadcasted element, and I'm also broadcasting all the messages that went through it to all subscribers. And yeah, I have changed the broadcast processor with a unicast processor, and I just need to change it here as well. And here, questions. Okay, so now the test should succeed because we eliminated this race condition. Yeah, it passed. Okay, so there's actually one last step I wanted to do. Because we can respond to questions now, but we have no scores, user scores for the questions, etc. So I'd like to add that. So I will add pro sign up and watch score. So I'm adding 2 new methods. One is to sign up, which will accept a username and return a status which will say OK, or the name is already taken. And another method that accepts an empty and returns a stream of scores. So scores is a message. So I think we've already seen that in protocol buffers you can do a collection of fields, like a field of a collection type, rather. So we are doing it here again, but here we also use a different message as a type of a field. So that's also possible. So use scores will be just have a collection of user results, meaning user name and points for a user. Okay, so let's get back to Java for a moment. Okay. I hope IntelliJ will do good and will refresh the generated sources. Yes. So, okay, so sign up. So I need to store points for user, and I need to store the information if a user is already registered. So I'll for the sake of presentation, I'll use a single map for both. I'll just do a map of string to integer. User points, or points by user maybe, points by user. And so with this map, when someone tries to sign up, where was this method here? I'll just do if points by user. So I'll do put if absent. So it will put if absent and try to put 0 points for the user that tries to register. It will return the current value under the username if it is already defined. So if this is not null, then I should return that the username is already taken. So let me do sign up, response, status. And the status will be equal to name taken in this case, else it will be OK. Oops, OK. So I can just return it. So unique create from item and sign up response, set status, status. OK, that was the easy part. Now we have to calculate the score. So when there is a correct response, what we want to do is increase the points for user. So I'll just do it. Put answer, get user, and the current points of the user plus 1. So 1 plus points by user get, answer, get user. That was simple. OK, so I'm increasing the points. I need to broadcast this. So I need to return something from word score. So I'll use the broadcast processor again. Broadcast processor. And use scores, I think it was called, right? Scores, broadcast. And from the word score, we can simply return it. Scores broadcast. But we also have to feed the broadcast processor, right? So I'll cheat again. Quiz broadcast results. So I have pasted actually a method that translates our map of points by user to this user, to the scores object, basically. So it translates every entry of the map to user score and then builds what we want to broadcast. So with that, I think there's only one last. OK, I need to call it from somewhere. So I need to call it from here. I need to call it from here. And we are, I think, really close to actually playing the quiz, if everything works. There's one tiny little thing. So with what I have currently, a user could submit multiple answers to a question and have a lot of points. So I'll add some set of users that already responded, maybe. Users with response. In collections, new set from map. Oops. OK. So with that, when someone tries to answer, and it's the proper question, we will do if you answered already, we will say it's a duplicate answer. So users with response add. So if it's false, add answer get user, and status will be duplicate answer. OK. OK, and on broadcasting the questions, we have to clear this. So clear, and broadcast here also clear. Clear. OK. So now we've played with grp curl, we've played with a test. So there's one more way you can work with your gRPC services if you use Quarkx. You can use something that we call dev-UI. So you can go to localhost 8080 QDev if you use 8080, the default port for HTTP for Quarkx. And then you have this dev-UI with a lot of nice information about your project. But among them is a gRPC tile. So you can click on services here, and you will get a list of services. So we have this hello gRPC help, and we also have our quiz service. And we can play with it from it. So I'll try to sign up. OK. I'll try to sign up once again. OK, didn't work. I'll watch the score. I'll try to get the questions. And I'll try to prepare an answer. So yeah, we'll see if it works. So I think it was how much is 2 plus 3 and the, oops, not this field. So maybe I'll copy the question. That would be faster. So like safer, maybe. So let me just, why doesn't it work? OK, I'm in the wrong window. So Riddle Storage, and there was how much is 2 plus 3? So that's the question. I forgot about one thing. Sorry. So right now I have this 2 seconds for the answer. Maybe I'll be able to actually pull it off, but I think I'll be too late for that. But let's try it. So admin, start. And let me quickly send the answer. Nope, already time. Anyway. Let's line as another user. Watch the score. OK, get the questions. And let's try it once again. So this with gRPC curl, you have to install something, and it's not easy. You have to know the syntax. It is not as simple as curl. You have to know how the message looks like, and so on. That's why we wanted to have this dev-UI to help you test your application easily. OK. That was our motivation. OK. Whew. I got it. So there's a correct answer this time, and Joe has 1 point. Anyway, so you can see that you can use. I only showed the server-side streaming, but you can also use the client-side streaming with this, and it seems it works. So what I'd like to do now is deploy this to some OpenShift instance and let you go through the quiz. But I'll first add some properties so that there's a bit more time to answer the question. It will be 5 seconds. And how do I exit this? Let's get here, maybe. So I think I'll let you see some slides and let Martin talk about them in the meantime, and I will deploy it somewhere. So
Michał is trying to deploy the demo on OpenShift, and OK. You've seen the dev UI for gRPC. It's important to say that we're actually trying to convert the gRPC messages into JSON so that it's human readable, right? Because as we said before, normally the messages are sent in a binary format.
What?
Yeah.
Sorry for that.
No problem. I don't need your slides, actually.
OK. I'll unify the endpoint.
Yeah, I just wanted to repeat what Michał showed, actually. We generate a mutiny-based interface that can be used for both the server and the client. So when you define the service, you implement this interface and add your business logic. But you can also inject this interface and use it as a client. And when using this in tests, we have a pre-configured client for you. which is basically normally you would have to provide some kind of information like configuration for the host port and so sorry, so on. So this is not necessary in the pre-configured client. We also had one slide about integrated metrics, but we don't have time to show it. It's basically when you add a Quakus micrometer to your application, then we collect the metrics about the server side and client side automatically. So that's all. You just add an extension and it's automatically collected. Success?
Not yet, not yet.
Okay.
It will take some time. I decided to compile the application to the native binary so that there's less to transfer to OpenShift, but the build will take some time then. So maybe you have some question in the meantime.
So it's still deploying.
It's still building.
So if there are any questions, cool.
First, thanks for the presentation. This is very stressful to do live coding. Your guys are brave. Could you please talk a little bit more about those metrics that you mentioned earlier?
Oh, sorry, about the magic in which area?
The metrics that are collected during...
Yeah, metrics.
Yeah.
Actually, I can't. Because maybe Michal can mention something about that.
No, I don't know the details. I know we have some.
Well, if you have time, you can come to the booth and we can just show you what we have in this demo, because once you add the micrometric extension, you can immediately see the metrics we collect. So that will be...
First, the service must be deployed, right?
Yes, sure. Sure.
Oh.
We're probably out of time, right?
So we can already probably scan the code. Oh, how do I make it bigger? Okay.
I don't know if this will work.
Come on. Let's do it once again. Sorry.
So they want you.
A bit too big? Okay. Is it scannable?
I'll try it. Doesn't work.
Sorry? Yeah, not yet. It's still deploying.
Application is not available.
It's yeah, as you can see, it's pushing stuff to OpenShift. Or maybe we'll just fail. Let me see. Okay, it failed. That's great.
So we're sorry about this failure, but yeah, we can try again at the booth.
Yeah.
So if you are interested to play a quiz, come to our booth. You will get a T-shirt as well.
Sorry and thank you for your attention.
Thanks.
Okay, we are having some technical difficulties. So we can't get my slides on. Let's just do
Are they hiding?
So just give us 2 minutes, please. Oh, wait, I don't know what that is. Okay, sorry for that. So I can't unify the display, so we're going to basically code like this because we're working off that screen. I'm Philip, I work for Red Hat.
I'm Jan, I also work for Red Hat. We're both in the Quarkx development team.
Okay, so today we're going to start off with a quick overview, and then we're basically going to get into the demo, and we might pop back to the slides every now and then. We're going to take an existing REST application, and we're going to actually convert it to GraphQL and show you that you can already code GraphQL because it's very similar. During that conversion, it's going to include the server side. It's going to include more than one client as clients. We're going to talk about source fields. We're going to show multiple queries. We're going to show map support, mutation, subscription, security, error handling, and non-blocking. We probably won't get to all of this, especially now that we are a bit late, but we'll do our best. So quick overview for those of you who don't know what GraphQL is. It's a query language, first of all, for your APIs, but it's also a runtime to actually fulfill those requests that comes in. So it basically gives your consumers the power to ask for exactly what they want. A quick history, it's been developed by Facebook, but it's now open sourced and it now lives under the Linux Foundation. It's been positioned as an alternative to REST. It does declarative data fetching, and Facebook specifically done this when they saw an increase in mobile usage, and they had to start playing with smaller real estate, so size became important. And they had a variety of different front ends that all have different needs on what they request from the server. And it allows for rapid feature development, and it's been around for a while. The main thing that we're going to show is that we are solving the overfetching and underfetching problem in REST. Overfetching means that I'm asking, I have a service that will get a movie, and it brings back all the data of that movie, and I actually just want the title of the movie. And then to get the cast of that movie, I need to call another service in REST, and it brings back all the cast, and I actually just want 3 members of the cast. So overfetching is it returns too much data, and underfetching is I had to make subsequent calls to get all the data that I want. So the existing REST application that's going to be our starting point is a movie REST API. It's backed by a movie service. We're not going to get into the movie service, but just to tell you, the movie service gets data from a database, the movie information itself, and then there's another service that returns cast members, so people that was involved in that movie, and that comes from IMDb as an example. It also has the model, so the model of what a movie is. A movie has multiple actors, the actor has a name, the actor played this character, and so on. And then we'll show the clients. So in the REST example, we typically have 2 types of clients, the JAX REST client, which is much more dynamic, and then the type-safe micro-profile REST client. Right, so let's show that. So now we're going to see if we can code this way. So this is is this font big enough? Can you read? I'll go a bit bigger. So this is a typical REST API. I've got a movie resource under movie. I inject my backend service. Like I said, we're not going to get into exactly how we got the data or how we get the data. It's just some service that returns data. And then I can search for movies. So under search movies, I'll return a list of movie references. I can get a specific movie if I have the title. And then I can get the cast members for a movie if I have the movie ID. Right, so if you use Quakus, you have dev UI. So if you've been to the Quakus talks up until now, you would have seen dev UI, but I'll quickly show it anyway. Localized 8080 Q dev. I must start my server, which typically would have been running if I wasn't battling with screens. Okay, so I'm starting up my application in dev mode, so you'll see that I won't restart any application as we build this going forward. Right. So in here, you've got all the things, all the extensions that's currently used in your app. We want to look at, not this one, we want to look at Swagger UI to show you the existing application. So as we said, we have search, so I can search for a movie. Let's try it out and search for The Godfather. Right, and I get a bunch of movie references back. I can also get a specific movie if I know the title. So the one that we're actually going to use is Top Gun Maverick, which I haven't seen yet. Right, and now I can get all the data around this movie back. It's quite a lot of data though, so it gets me the company that was behind it, some awards and release dates and a lot of data. And that's the overfetching problem, because I'm building a mobile site, so I'm only interested in the top actors and the name. Right. Now this doesn't have the top actors in, it only has movie data in. So what I need to do is I need to go and get the ID and then go to another endpoint, which is cast, and then say, okay, now also get me this. And then I get the full cast that was involved in this movie. So this is the directors and the actors and the writers and all of them. I'll probably have to filter it down to the exact data that I want, merge it with the original movie data to actually get to displaying it on my screen. And that's the problem we're solving with GraphQL. Okay, so let's get back into this. So what we're going to do is we're going to, this is our original design. What we're going to do is we're going to replace the movie and cast member with a movie GraphQL API. And then we'll replace the two clients with a dynamic client and a type-safe client. And this is where I'll show you that you can already code GraphQL endpoints, because if you know REST, this is very, very similar.
Okay, I will talk a little bit about the clients. As Philip said, in the REST world, there are two types of clients, at least in the Java world. The microprofile REST client and the JAX-RS client, where the JAX-RS client is a bit more dynamic, and the microprofile REST client is kind of more type-safe because it works directly with your domain classes. And in GraphQL, at least with microprofile GraphQL, it is kind of similar. We have a type-safe and a dynamic client. So the dynamic client contains basically a domain-specific language that allows you to dynamically construct GraphQL queries that you can then send to the server. And back from the server, you receive data represented as JSON objects. With the type-safe client, you code your classes that represent the data, and you request these objects. You get them back right as the objects. Both client types work for HTTP, work for all types of GraphQL operations. We have three types of GraphQL operations: queries, mutations, and subscriptions. Queries are the operations where you basically ask for data. Mutations are operations where you ask for data and then the operation can basically change something. So query is basically a read-only operation. Mutation is something that can not only return data, but also change some data. And subscriptions are operations that return multiple results. That means you can basically subscribe to multiple future events, and that works over WebSockets. Queries and mutations run over pure HTTP requests. Or you can also run that over WebSockets if you prefer. So let's go on.
OK, so let's get back to the code. So what we're going to do, I'm going to copy the existing REST endpoint and paste it in here. It's quite difficult to code like this. And then we'll zoom it a bit again. So to show how easy it is to convert it to, we'll basically just remove some annotations and change a little bit of code. So we'll start off by saying that, obviously, this is not REST anymore. This is now a GraphQL API. We're still going to inject the backend service because we get the data from the same place. A get is basically a query. We're getting data, so we'll say that this is a query. And we don't need to have a path parameter. We're not tightly coupled to HTTP like REST typically is. This is also a query, so we'll just say that this is a query. And again, we don't need this. And with this one, what we're going to do is we're not going to make it a query. We're going to say that if somebody asks for a movie, which comes from the database, we can add cast members. If they are interested in the cast members, we want to add cast members to movie, even though we fetch the cast members potentially from a different source. The way to do this is that you'll say that if the source field, so if the source field is a movie, then attach a new field onto movie called cast members. So now, and then make that queryable as well. So movie.id. And you can do this, and we'll go into this in a bit more detail, for anywhere down your object model. So any field in your object model, you can start attaching things to it. So this should be enough to get us going. So let's get back here, and let's go back to Dev UI. So very similar to Swagger UI, there's a UI for GraphQL called GraphiQL that allows you to test out your GraphQL code. So let's start with getting a movie. You'll see that I have code inside here. It's because by default we generate a schema where with REST you have to attach OpenAPI or something similar to document your endpoints. This happens automatically in GraphQL. So the title of the movie will be Top Gun Maverick. Right. And then now I can start saying what am I interested in? So we're only interested, let's say, in the full title. And then, as I said, we might be interested in some cast members, which is now available due to that source field that I added. So I can say also get me the cast members. And it's queryable, so I can say I'm actually only interested in the actors, not the writers or the directors. And for the actor, I really just want the name and the character that they play. And then that's the data that it returns. So I'm already solving the over and under fetching problem because I can exactly ask what I want in one request. I think we can switch to the client now and first show how we do this in the client.
I can show how to do something similar with the client. Yes, to get a movie. So my application that I have here also is based on a REST client. This is a movie REST client. As a command line application, so I will run it as a command line application in Quarkx dev mode, and I will, each time I execute it, I will pass as arguments what I want to do. So if I run this in dev mode, here, what was the operation that we wanted to do? Get, right? That was get movie. So I will pass that I want to do, that I want to, for now, I want to just show that how my application does it with MP REST client. And I want to do operation named get. So I received basically the same that you saw with previously in the dev UI. I received all the over a REST client, over all the information about the movie Top Gun Maverick. Now I'll do the same with types with a dynamic GraphQL client. So I have another class here that I will use where I will do basically the same, but I will do it with GraphQL clients. I will inject my GraphQL client here. This time I will inject an instance of the dynamic GraphQL client. I need to tell which one it is because I have multiple dynamic, I have multiple GraphQL clients defined. Its name is movies. It's really odd to type to code like this. It's not on my screen. Okay, so this will inject a dynamic GraphQL client. I have it configured in application properties under this same key. I basically only this property is relevant to this dynamic client. The only property that I have to add is basically where the URL target is. So I have this property that says, look into the contents of the URL. In our case, it's on localhost. Well, first we wanted to do this with two laptops, actually, client and server separated, but then we said, yeah, that's way too dangerous for a live demo, so we're doing it on the same computer. But you can imagine it's two different computers because we're using two different IDEs. So this is how I configured my dynamic client. Now, in the application, I can inject an instance of it like this, and I will now implement the get operation. So if somebody asks me hold on, yes, this was with the dynamic. Sorry, also this operation was for the type-safe client. I'm completely messed up. So this is, I need to inject my type-safe client. I will inject both because I will be injecting both anyway. So GraphQL client, movies, type safe. Okay, so the operation get. What we will do is type-safe client, get movie. I will just hard code the title here to make it easier. So that was Top Gun Maverick. And let's have a quick look into the type-safe client class, what it actually does, what it looks like. If we look at the query here, it's an interface. It's annotated with GraphQL Client API. So it means it's a type-safe client with this configuration key, just like with the dynamic client, it also had a configuration key. This one has a different configuration key to be able to configure where it connects to. But the most important thing is that I will be asking the server, I will be invoking a query. The query is named movie. That's derived from the method name. If I name it getMovie, it turns that into movie, right? It assumes that the operation name is movie. That query has one parameter named title, and it returns a movie. So I have a class named movie, which basically contains the same set of fields that correspond to the fields on the server side. So I can now call this, inject a type-safe client, get a movie, and store that. Because it's a type-safe client, I get a movie directly, and to kind of show what actually we receive back, I will serialize that into JSON, so you can see in the log what we actually receive. Now I will rerun the application, saying that I want to use GraphQL and do the operation named get. Perform the operation named get. And here you can see that I received the same, that I received a movie, Top Gun Maverick, with the ID, full title, year, whatever. Again, at this time I requested all the data because the movie class, contains all the fields. But if with GraphQL, I can receive just only the data that I want. So if I removed any of these fields, then these fields wouldn't be fetched, and basically, this server wouldn't have to send them back to me. This is how the type-safe client works. If you want to receive less data, you just don't include these fields in your domain class. Okay, that's it for now for me.
Okay, so what we want to do next is we want to go deeper into the graph, and what we want to try is we said that all the cast members is too much. I'm only interested in the top 3, the stars of the show. So what you can do is add another source field. This time, we're going to add it on cast members. So we're only interested in the actors, the main actors. So now I say that if there's a cast member, actually allow me to pass in the limit, and then we'll just filter out the rest. And that, as you can see, you can actually build a graph as deep as you need. In any of the models, you can add the source field to do exactly this. Right, so let's save and quickly show that. So now, rather than actors, if I just refresh the schema, I now should have a field on cast members called main actors, which I now need to pass in the limit. And let's say we only care about 3. Right, so now my response is much smaller, first of all, and exactly what I wanted.
Yeah, I can show this with the client.
Yep.
I will cheat a little bit to make it faster. Okay, so this time we're basically, again, invoking the same query. It's, again, the movie query, but we're requesting different data. So I have a different class ready for that. Yeah, this is the query that we will be invoking. This is, again, the same. operation in our case is main actors. It will invoke the same query, movie, but it will request only basically only the cast members field. So how do we do that with the type-safe client? Well, we have a class specifically for this, and this class I named movie cast members only because it's a class that represents the movie type, but it only contains one field, and the field is cast members. And in our case, and if the cast members is of type cast members with main actors, and that contains some fields that don't have to be here there, but also the main field that is what we're talking about here, and that the field is main actors, and that's a list of actors. So we have separate class with different sets of separate class with their different sets of fields. So it means we will fetch a different set of different kind of data. So as I said, I will cheat a little bit and just do this. And so what I do is, again, using the type-safe client, I call the get main actors. Yeah, I should probably show also the declaration of that method. I called it get main actors. I had to set the query name because it actually calls the same query on the server. The query is again named movie. If I just left it without specifying the name of the query, it would deduce that the query is named main actors, which it is not. It's named movie. So I had to tell that the query is named movie. So it's the same, actually the same query as before, but I receive a different type. So I would request a different set of fields. The query has, again, this one parameter named title, but there's another parameter that was, in this case, added, and that's the limit, how many main actors I want. And that it's a nested parameter. If you look again at the query, you can see that the limit parameter is nested inside the cast members field and inside the main actors field. So how do we specify that? Well, using the nested parameter annotation you see here, cast members dot main actors. That means that this value passed to this method, to this argument limit, will actually be transformed into a value for this parameter inside the query. So I specify the title, Top Gun Maverick, the limit will be 3, and I'm interested in the main actors, so from the class I get the cast members, and from the main actors. Now I can actually invoke it. I want to use GraphQL client, and the operation is named main actors. And you can see I received, Val Kilmer, Miles Teller, and of course Tom Cruise, the three main actors in the movie.
Okay, so that's basically source fields. What we want to show next is that we've added support for maps. Now, it might sound like something that just should be there, but in the GraphQL specification as hosted by the Linux Foundation, there's nothing like maps in GraphQL, and the reason for that is that a map is very difficult to traverse and build up a schema, because a map is just this dynamic thing that contains keys and values. So I can have a map that says my name is Philip and my surname is Kruger, and I can't build a schema up of that because I don't know what's in that map to say that name is a field and surname is a field. So there's no such thing as a map in GraphQL, but because it's a popular construct in Java, we added support for it. And the way that we added support for it is we first added support for adapters. So you can build your own adapter and say that in Java, this is the class I want to, in GraphQL, adapt it to this class. We're not going to show adapters today, but just so that you know that this exists. And it's very similar to JSON-B adapters if you've ever used that. And then we've, on top of that, built some adapters that's included, like adapting a map. The way in which a map will be represented in GraphQL is a list of key value pairs. So, and if you're a viewer, for instance, in our case, the reviewer is an enum, we actually have some insight on that field, which I'll also show. And then we've also added, by default, if you use maps, the ability to pass the key in, to query a specific key in a map. So let's see this. Did I save? So that's ratings. So we'll remove cast members just to keep it small. And then I have to refresh to get the new schema. So now I have a field called ratings. And at this point, it only has a key and a value, right, which doesn't mean much. And now we have an error. Let's just see. I have an extra. Thank you. It's quite hard to code like this. OK. Right, so now I get my map back. But as I said, you can also, by default, it will be built in having the ability to query by key. And because this key is an enum, you can actually say that let's see what did we rate this. So we gave it 9.4. Right, are we showing this in the client?
I will show this in the client together.
Oh, when we do the mutation. OK.
Later.
Right, so next we want to move on to mutations. Up until now, we've only fetched data. A mutation, like we've said before, allows you to change data. So that means edit data, delete data, or add new movies, for instance. So it's very easy again. You annotate your method with @mutation. We're again going to return a map. And what we're going to allow you to do is to rate a movie. I'll show this a bit later. So for now, I'll delete this. So it's a very basic method that takes in the ID of the movie and the rating that you gave it. And then actually calls the backend service that does the work. Right. So to show that, so at the moment the rating is 9.4. We want to do a mutation, rate movie, and then now refresh this to get the latest schema. So now I can rate the movie and the ID I didn't get. Let me just quickly get the ID here. So this is the ID, so we want to write this movie. I think this one will just be the one that we want. Oh, I could have just done this. Right, so let's write the movie. We actually went and watched the movie, and then we thought it wasn't really good. Right, and we only care about Quakus for now, so in the return results, we'll unreturn whatever we've rated it. So now I've changed the data. This could be a database call that actually changed the data in the database. Right, so let's show this client for this.
Oh, yes, do I have that in the client? Hold on. Actors, mutation, yeah, the operation rate. So again, I will cheat a little bit. This is again showing with the type-safe client. There's nothing special here. I have the type-safe client contains a method named rate. I marked it as a mutation so that the client knows that it's executing a mutation. It has two. In our case, 2 arguments. In Philip's case, it was 3, but the key is not required, so I left it out. and it will be assumed to be Quakus, and it returns back a map of all currently known reviews of that movie. So I will basically call this method with specifying the ID, and I liked the movie slightly more than Philip did. And I will, after I receive a result, which is a map of all known reviews, I will just print it out. So let's execute this. I want to use GraphQL, client, and execute the rate operation. And here you see that's the result, that the rating from the Quakus community has risen to 8.3 now.
All right. So we've done queries, we've done a basic mutation. The last main operation in GraphQL is called a subscription. So that's when you are interested in data and you want to subscribe to data. So what we'll do is we'll add a subscription that says that we are interested when the rating change. We use Mutiny to do this, and we use the multi-object to basically stream this for us. All right, so somewhere in my movie service, there's a broadcaster that broadcasts every time that somebody rates the movie, and then we want to stream it down to the client. Again, very simple. You just add the subscription and you return a multi. So to show this, what we want to do is we want to keep this open because we want to do the rating, but we'll open a new browser and then do the actual change of the rating. Right, so here we'll do the subscription. We'll say listen for a rate change. And there's no arguments, and now we can just say, okay, let's see what was the Quakus rating. So as soon as I started, it's now opening a web connection and it's waiting for data. Right, so now if we, Jan convinced me and I said, okay, maybe 5.5 is a bit harsh, let's give it a bit higher. Right, so now we will receive the data there. And every time that I went and saw it, I liked it more and more. So it keeps on streaming the data.
Yeah. So I will show the same programmatically now. And this time I will use actually the dynamic client, not the type-safe client. So this will be the code. This is what the dynamic client looks like. As I said, it's a DSL for building GraphQL queries. So here I built an instance of a document. Inside the GraphQL document, there's an operation. That operation is a subscription. The operation name is listen for rate changes, and here I say which field I'm interested in. So in this case, let's ask for the ID of the film, which that was rated, and for the Quakus rating and for the Metacritic rating. So this way I built the document actually that describes what I want to ask the server, and then use the injected dynamic client instance to execute the subscription by calling the subscription method that returns a mutiny multi. So I have to subscribe to it, and my subscriber, what it will do is basically just dump it into the printout. And I'm using a dynamic client, so I will be getting the data presented as a JSON object, not as any kind of Java class. So I will optionally, you can convert that, of course, to domain objects. But in this case, I decided to just keep it as a plain JSON object. So each item that you receive is basically one response from the server after each event. And the data, the type of this data is, as you can see, Java XJSON object. So I will just dump that JSON object into the log, just the raw data. Now I will execute it. Listen. And now,
I can quickly show that. I've got that script.
If you can open it in the browser in the GraphQL UI. Now, what it did now is that it initialized a WebSocket connection to the server, and for this particular subscription. And now it's waiting for events for new ratings. So when we actually perform some rating like this, gave it 7.7. Now you can.
You need more space.
Yeah, and you see that there's already in the log. You see new ratings, Quakus 7.7. If you do it again, it will keep that WebSocket connection open for as long as you need to receive notifications about new ratings for this particular movie.
Okay. We are running out of time because we had a late start, but let's do the next one. Yeah, so next I wanted to show reviews. Now, the reviews we're actually fetching from a different data source, and it's also non-blocking reviews, so I can return it as a uni. So we support non-blocking either by returning a uni or by annotating your method with @non-blocking, like everything else in Quakus. And then we'll just return the reviews. So we add a new source field on movies, which will go and grab the reviews from another source, not our database, and add that to our source. So we now have, let's get a movie again. And now I should be able to get a review. What did I call it? I didn't save. Oh, and I miss a, nice, thank you. Okay, save. Right. And we'll just get the top review back for now. And let's just get the content back and maybe the title. So like I said, this typically comes from a total different source. That's why it's taking a bit longer as well. It's actually making a call out to the internet to some place where we do reviews. But now I have the review. So let's say that site where we get this data from is not available, right? So we'll simulate it by just throwing an exception and pretend that we've tried to get the data, but we couldn't. So if I do it now, I can still get back the data that I could find, which is the movie title, or any other field on the movie. But then the reviews I couldn't get, so I can get partial results back. So if you are aggregating data from different sources and some of them aren't available, we will still return as much as we can. So that's called partial results in GraphQL. So next I want to show how we do security. In GraphQL, it's as simple as basically adding, let's say only admin people can do. Actually, let's do it on the mutation. So only admin people can do the mutation. So we don't want everybody to be able to rate a movie. So we add roles allowed on admin, roles allowed on rate, and we say admin can do it. So this is standard. It works the same for arrest and so on. What I also need to do is add a security provider, which is in my POM. And I'm going to add OpenID Connect. Because I'm using Quakus, it will start up Keycloak in the background for me. If I don't have any configuration, it will start up Keycloak using dev services. Right, so if I go back here and I do a rate again, so let's rate the movie again, I should get an error. What did I do wrong? Rolls allowed, that looks right. Sorry, let me just see what happened here. Yeah, Quakus restarted, which is fine because we've pulled in the Keycloak server. I'm not sure why this is happening. Let's just go.
Well, do you already need to log in?
Yeah, let's see if we can log in and actually get the data. I wanted to show the error, but so now I have. I should have a new extension called Keycloak somewhere, which is what dev services gave me. I can log in. I can say that I'm an admin, which is Alice and Alice. And now I'm logged in. And you can do all sorts of things like viewing the token and so on. What we're interested in is actually saying go to GraphQL, and be logged in. So now it works. And the reason for that is because we've actually set the request header. Right. Are we out of time? I think we are, right?
Pretty much, yes.
So we wanted to show quite a lot of things still, but I think we're out of time. So I think we should rather see if there's any questions and then
let's show the summary slide.
Yeah, we can show the summary slide and then.
And then open up to questions.
Yeah. Yeah, so we've shown source field. I didn't show multiple queries. Basically, multiple queries allows you to, if you say get movie, I can have another query that gets another movie that has less fields or more fields. So I can combine as many queries into one. We've shown map support, we've shown mutations, we've shown subscriptions and security. I've kind of shown error handling. We also support bean validation errors and normal exceptions and so on. And non-blocking we spoke about. We can also do transformations and mappings. So typically if you want to, you have a double, but you want to map it to display it as a amount, so it has the dollar, and you format it a bit. You can do all of those type of things. Adapting, I spoke about, so that's how we've implemented map, but adapting from a Java object to what you want to represent in GraphQL. There's a context object, which I didn't show, but anywhere in your application, you can inject a context object, and this will give you context of the current request. So this is typically useful for downstream operations. So if you want to, for instance, know what this person has asked for and optimize your backend query. Batching allows you to batch to be more efficient, and we haven't shown that. Introspection allows you to use GraphQL to query GraphQL's schema. Directives allows you to define your own directive. We're starting to use directives internally to support federation and so on, and we'll start opening it up for users to build their own directives.
We can also generate, by the way, directives for bean validation constraints.
Oh,
if you have bean validation constraints on your domain classes, then they will get transformed into GraphQL directives. Yeah, integrations. Yeah, you can use to customize how the classes are transformed into JSON. You can use either JSON-B annotations or Jackson annotations. Both are supported. Security, we showed that. small right context, we talked about that. Bean validation also talked about that. Yeah, and you also get metrics. We support both microprofile metrics and micrometer. We also support open tracing. You can get tracing data from the invocations of your operations. That's, and
yeah, we can quickly go through. We can maybe start taking questions. Are there any questions? There's a question in the back.
Is there a tool that helps you fetch data from the database more efficiently?
So like I've mentioned, the context, so you can build it on your own at the moment by looking at the context. We're also going to work on something like, for instance, Blaze persistence. We'll work on that to see if we can't let Blaze persistent look at your database and then create your GraphQL. But at the moment, nothing built in. No more questions? Sorry, I can't really see if there's hands. So I'll quickly just run through the roadmap. We want to add some more built-in directives, like, for instance, the ability to just say add pageable on top of your method. And if your method returns some sort of a collection, we will make it pageable automatically with some directive. Same for filter or limiting. So just basically doing the boilerplate stuff for you. Add support for federation. Allow you to build custom scalars. So a scalar is like the leaf node, like a primitive in Java, strings, integers, booleans, but allow you to build your own scalars. And that's it.
Okay, that's the summary. We showed how moving from REST to GraphQL is easy, especially with Quakus on both the server and client side. GraphQL lets the client ask for exactly what they want, and the server will respond to it with exactly what the client wants. And anything else we have there? Yeah, out-of-the-box integrations, metrics, tracing, security, everything. That's it.
If you have any questions that you didn't ask now, please find us or reach out online to us and ask us. Thanks very much.
Thank you.
Awesome. So welcome, everybody. Last talk of the day, and thank you for your patience while we played with projectors. It's 2022. You'd think it was a solved problem, but that's how these things go.
Yeah, it's solved for Mac, apparently.
So, Georgios.
Hey.
Hey, how's it going?
Good, good.
So you know how you told me about Quakus a while ago?
Yeah.
Yeah, I went back and I took one app and I converted it to Quakus and I put it in production. And then I took another app and I converted it and I put it in production. And now,
easily.
Yeah, and we've done the whole estate. We've got 300 apps in production. It's going amazing. Where our cloud costs are lower, our developers are happier. In fact, it's going so good. We have a problem.
Oh, what's that?
We got acquired. and our new CEO, he's a little bit of a character.
What kind of character?
Well, he's got some requirements for how we should be doing things.
That's how it all starts, isn't it?
Yeah, and they're not ones I've seen before. And in particular, he's got some ideas about how we should do observability.
Unique ideas?
Unique ideas. And he wants them done tomorrow.
Well, that's better than yesterday.
That's true. Across 300 applications. So, since you helped me out so much last time, how do I fix this?
Well, I would say Quarkx extensions to the rescue.
Ah, cool. So, I guess, like, what kind of, is there an observability
Well, yeah, I mean, I don't know what the requirements are, but we have a lot of out-of-the-box, I don't know, like OpenTelemetry.
Oh, no, OpenTelemetry, it's not what he wants.
Micrometer.
No.
Open tracing, Jaeger.
No, he's a bit more specific than that.
Okay, so it seems like we're going to need some kind of custom solution.
Yeah, so extensions, eh? So I guess, hands up if this is your first Quarkus talk of the day. Hands up if you've been to other Quarkus talks of the day. Oh, good.
Excellent.
It's always sort of reassuring to just do that,
to
check
see if
some. Yeah.
The sum is 100%.
Yeah. So I think this will be quite familiar to you, but just to refresh, we have Quarkus Core. And then there's a whole bunch of libraries out in the world that we all love. Netty, JaxRS, Hibernate, JWT, Elasticsearch, Grpc, whatever. And just because I'm using Quarkus doesn't mean I don't want to use all of those other things. In fact, I definitely want to do them. So I want to connect them in. But when I connect them in, I don't just go straight in. I have an extension that acts as a bridge between Quarkus and the other things.
Very true.
Yeah. And this is sort of for lots of things. And we call this the Quarkiverse. And so the next question is, why would we do this? Netty was pretty good. Grpc is pretty good. And to think about why we want to do this is we're sort of going back to, why are we even using Quarkus? What's special about Quarkus?
Right. So that's yeah. I'm sure like folks heard like a lot of Quarkus stuff, but let's just recap and explain like why this information is important for Quarkus extensions. So as you see here in the slide, the usual way that traditional frameworks that I'm not going to name, but you can like use your imagination, work is that at build time, all they do is like invoke your build tool to package all your code, right? They don't have any logic at build time. And everything that the framework needs to do is done at runtime. So like class path scanning, I don't know, file parsing, metadata generation, whatever. All that stuff is done at startup time, right? That's the traditional way. It's been around forever. It's worked great so far, but it has some inherent limitations that it takes up a lot of time to start, takes up a lot of memory that costs now in the cloud native age. So what we do with Quarkus is we try to move as much of the processing to build time, right? So all the class path scanning, all the like checking annotations, all the parsing of persistence XML files, whatnot. All that stuff is done at build time. So we create an optimal, let's say, jar file in most cases, or a native binary. And at runtime, all that the code needs to do is like just run a few steps with all this pre-built information that we've obtained at build time, right? And that has a lot of benefits, like you already explained, and like folks have already seen in other talks. Also, yeah, it enables GraalVM native binaries, which are very hard to do for anyone who's tried it, like without a framework. It's really hard to do, but with Quarkx, it's just a breeze.
Cool. But then I guess if you've got a normal framework and then you put it on top of your cool Quarkx stuff, what happens?
Yeah, so that's a very good point. You could do nothing and like just let the framework do whatever it does, but that would in some ways negate your experience, because maybe that framework is doing class path scanning on its own. Maybe it's like parsing all this XML or YAML or JSON, whatever, or maybe it's creating dynamic proxies. All that stuff is what we've worked very, very hard in Quarkx to remove, right? All the reflection, stuff like that. So a lot of the times you would want to go the extra mile, especially if this is like a very important use case, to enable the type of work we've done in Quarkx, to enable it for your custom library or framework.
Cool. So then I guess, yeah, when we bring in the framework, we're back to this bit where we've got everything at runtime.
Exactly, yeah. This is basically the steps we just described. Yeah, you can see them again.
That's a bit tedious.
So yeah, if we initialize a build time, the result of all the work we do is that we do a lot of this stuff, a lot of this work once, and that's a build time instead of, let's say, if you're running Kubernetes and you need to scale like to 100 pods, you don't want to do like 100 class path scans for each pod. Sorry, you do it once. You get rid of a lot of additional code, for example, for parsing XML. You don't need that because that's already done at build time. Obviously, we start a lot faster, use less memory, and less or no reflection, which is like on its own, it's not like a huge goal, but it results in better runtime performance and footprint.
Cool. Yeah, and then you just got that tiny little bit at runtime.
Exactly. Yeah, we're starting threads, like reading files, whatever.
Cool. And I guess there's another side to it too, which is that with Quarkx, there's that fast footprint, fast startup, small footprint. But then there's the developer experience as well. And it's not just a developer experience, it's proper full-on developer joy, right? And I don't actually know if this is what happened. I wasn't there at the start of Quarkx. But I sort of imagine that someone said, you know, we've done all this work to make it work with native. We've got like so into the bytecode, and we've moved everything to build time. While we're doing all this work, couldn't we make coding easier? Couldn't we get rid of all this boilerplate? And so then what we've got, the sort of, like we can talk about developer joy, and that's kind of generic, but there's some really specific things that we do. So there's the dev instances where when you're coding, it just magics up something for you to code against. And you've got that config, so that instead of having your config scattered across a different file for each framework, it's all in one place. And then you've got all these opinionated shortcuts as well, so the boilerplate just goes away if it's not adding value. So like if you're using Hibernate, for example, normally you have to make this persistence XML. And the reason you have to make it is because it would be really annoying at runtime to scan every single library to see if it might have some annotations. But since we can do that at build time, you don't need the persistence XML. And you see this sort of everywhere. And I sort of like to think of it as, it's like it's dynamic in terms of the user experience, but in terms of the performance, it's like it's static.
Yeah, it's static because at runtime, all this stuff is found once, and it's not reinitialized like every time. You can't, in almost every case imaginable, you don't like generate classes on the fly based on user input or stuff like that. Or you don't expect a user to provide like a persistence XML file posted in a form or something like that.
Cool. And so then, like, as another example, if you're doing Cassandra, normally you'd have to do all that, and you'd have to sort of get your cluster builder, and then you'd have to do it, and then you'd have to remember to close it. If you're using Quakus, you can just inject it. And I think what I really like this sort of phrasing that, what it's doing is it's being opinionated, but it's also being educated because it can see what you've got, so it can make good choices. So then that's sort of for extensions in general. Hopefully that's a pretty good set of reasons of why they exist, why they give value. So you get, if you're wanting to run in native mode, you probably need an extension to even make it work at all. If you're running on the JVM, you're probably going to work without the extension, but it's going to be a lot faster and a lot smaller if you've got the extension.
Absolutely.
And then if you want that good dev experience, there's something that as an extension writer you can do to get there. And so because of all those reasons to have extensions, there's a lot of extensions. So if you go to code.quarkx.io and you sort of look to see what you might want, you sort of scroll down and 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 scroll down, and then you keep scrolling, and then you realize you really should have put in a filter because there's a lot in there. And then you keep going, and then, oh yeah, you got to the end. And of course, that's just for the sort of the main platform. If instead you want to look at the third-party extensions as well, then there's even more. So if you change your filter, we've got
a whole bunch more.
A whole bunch more. So with so many extensions, is there even any point to this talk? Because there's a lot of extensions out there. Surely the world doesn't need another extension.
Well, I don't know. The new boss has pretty particular needs, so.
Yeah. And so I guess, if your favorite library doesn't have an extension, then maybe one should be written. Or if you are a library maintainer and there's no extension, then maybe it's worth looking into having one. Or as well, if you've got something where you're not really intending to give it out to the community, but just in order to make your build environment work, in order to make your development environment work, you need something that's particular to you, then an extension can be a really nice way of doing it. So as an example, we've got a Zulip forum where people ask questions, and someone asked recently, is there a way to hook a build step because I'm doing UI development and I'm sort of having to do these two things every time, and it's kind of annoying to have to do the two things every time. And the answer in this case was, yeah, we all agreed that was annoying, so we already wrote the extension. You can go look at it. But I think if that hadn't been the answer, then an extension would have been a good way of doing some of those sort of build customizations.
Absolutely.
So if writing an extension is a good idea, then the next question is, how does one write an extension? We're going to do a demo, but I want to run...
We're going to try to do it.
The technology is working so well. What could possibly go wrong? We're going to try and do a demo, but I want to run through some of the concepts first before we actually show the code. So the first one is deployment and runtime. All extensions have a deployment part and a runtime part. This is really just the build phase and the startup phase. So just like Quarkus, it's got its deployment phase, it's got its runtime phase, and what we try and do is we try and get as much as possible from runtime to deployment by turning it into bytecode. The extension should be doing the same thing. So get as much as possible from runtime to deployment by turning it into bytecode. And so then some of the things that you should be doing at deployment is go through, understand the app, convert any annotations that you find to bytecode, and then do some of these optimizations that become possible because you understand the whole system. The next important concept is build steps and build items. So when you're writing an extension, the first thing you'll do is you'll define a whole bunch of build steps. And each build step will have inputs and outputs. The inputs and outputs always take the form of what's called build items. And what happens when your extension runs is that the framework will take this sort of big pile of build steps, which define input build items and output build items, And it will magically order them, because it can kind of see, well, this goes into this and comes out of that. And then it will wire them together. And so those build items are the communication mechanism between the build steps. And there's some build items that run at the beginning, and there's some build items that run at the end, so things like making it into a jar, generating a resource. Most build steps run in the middle. And if you're writing an extension, it's those kind of build steps that you're probably looking at, unless you've invented some new form of packaging or something like that, which is possible. So when I was learning to write extensions, one of the things that I was sort of a little bit, it took me a while to sort of figure out, is all of these build items, do I write my own? What do I do? And I eventually worked out that there's basically a library of build items, and almost anything you would want to do in your extension is probably already covered by an existing build item. So what you just need to do is find the right build item and then chain it together with whatever the right thing is for your extension. And to find the right build item, it's on the web, of course. So there's a page that we've got a link to where you can just go and you can just browse what the build items are. And there's a servlet build item, there's various kinds. Next important concept is the index. So the index is all of the classes that Quakus knows about. And what it supports is if we make the index of all of the classes that we know about, we don't need to scan the class path at runtime, which is a very good thing. In Quarkus, that index is called Jandex. And the reason we have to have the index is because Quarkus operates in a closed world. So if you have an open world, it's really, really hard to do that build time optimization because you don't know what's going to happen at runtime. If you have the closed world, it's easy to do the optimization, which is why we do it. But in an open world, if something just comes onto your class path at runtime, there's no problem. If you've got a closed world and something comes onto your class path that you didn't know about at build time, it doesn't exist, which could be a real disappointment to the person who is hoping to use that class. And so that's why we have to have the index. And one of the things that you can do with your extension is you can add these extra classes that maybe Quarkus didn't know about for whatever reason. You can use an additional being build item, get them into the index. And I think the final concept is bytecode recording. Because in Quarkus, we want to do a lot of bytecode manipulation. Hands up who wants to write ASM. Yeah, OK, so there's a couple of weirdos who are on the Quarkus team. But luckily for us, they're on the Quarkus team. For the rest of us who really, really don't want to write ASM, what you can do is you can just write a class that does the thing that you want to happen. Quarkus will play that, watch what happens, and then replay that at deployment time. And it's called a recorder. We've got an example of a recorder here, but we're going to show it in the demo, so I will skip quickly past. Oh, and the last concept is configuration. So Quarkus, it's got its deployment side, its runtime side, and then your extension has those two as well. One of the nice things is that configuration for all of them comes from the same place. So you've got this application properties, and then you can just add whatever you want in there, and then it's accessible to your extension. And so with that, I think we can show some of this. Well, we can try to show some of this. So we're going to sort of do a laptop switcheroo as well. Because it turns out, if you take someone who's used to Linux and you tell them, can you do a demo live in front of lots of people on a Macintosh, it's not as easy as you would think as a Macintosh user.
Yeah, I at least maybe other people can do it. I can't.
No, we spent a little while this afternoon going, what's this command key and where's the control key and why does nothing work? And then,
OK.
Yeah.
So let me get some water because this is going to be tough. OK, it's going to be tough for me because I don't have the code in front of me. So whatever you see here is what I'm seeing. I don't have a screen. OK, so what we said earlier, excuse me? Oh, I think. What we said earlier is that what we want to do is we want to take generic applications that you've written in Quarkx, and we want to make them observable in this unique way, right?
Unique.
Yeah. So the idea is that originally we have a Quarkx to-do application, which is a very simple application. It's just has a JAX-RS endpoint, and it just serves a to-do list. It uses a database, and it has a UI, and we'll see how it does. But it's just a generic Quarkx application, right? And we want to instrument it in a way that, like when supposedly when we want to when a get a HTTP REST endpoint is called, we want to like do something like, let's say, log something special in the console, right? We want to say that this method was called. Just for starters, that's what we'll do. We'll say like when HTTP get method was called, then we'll just print on the screen that this was called, right? That'll be really simple because like boss man wants to see something simple first, and then we'll get to the more important thing that he wants to see. So what do we do, right? Because Holly said earlier that we had like 300 applications, right? So we need an extension, which we want to develop and then just plug into the application and have it just work magically. So what we've done here is that this already has the extension ready. It's already configured inside, or it should be configured somewhere. Okay, so we're calling this extension whatever, demo, Minecraft, or whatever. So it's already plugged in, but it doesn't have any code yet, right? So let's start writing some code. So what we want to do is, initially we want to intercept the logs, right? So what are we going to do? We have a deployment module and a runtime module, as we said earlier, and we need to split things out. So we're going to start by writing some code for the deployment part, and what we're going to do initially is say demo processor. We're going to go feature. We're going to go build item. Oops, wrong. As we said earlier, we need to create build steps. So build step, and it's going to be public void feature. And we're going to, not void, sorry. This is a feature build item.
There's a nice, if you're writing your own extension, there's a nice little Maven plugin that will scaffold it all for you. So it will create the POM, it will create that file structure, and it will create this first thing that George is struggling to type because he's having to do it turned around to do the first build item. Okay, so yeah, this is just going to be printed on the screen of the application like when it starts, right? So that doesn't do anything. What we really want to do is, say here, we want to intercept the logs. So what we need is a log handler build item, right? So this is going to allow us to create a log handler that will do whatever we want with the logs, right? So we'll go build step, and this is going to be executed at runtime. So we're going to say runtime init. There's a lot of details here, but you don't have to worry about it for the time being. We'll just say that what the important thing to note here is that this part will run as part of your application, not on static runtime, but like when the main, let's say your public static void main runs, which is generated by Quarkx, by the way. But that's not really important. So what we need to do here is we need to find a way to return this build item, but let's see what it takes. It takes a value of a runtime value, which means that it's produced at runtime, and it's optional handler. So we need to find a way to actually see how we're going to get that value. So we need to go to the runtime module, and we're going to say demo log handler. And we're going to call this a recorder, because we're going to mention that this is recorder, because as we said, we need to make Quarkx do some bytecode generation here. We're going to return the thing that we were expecting earlier, which was the optional
of log handler. No, sorry, it's not log handler, it's handler. And I'm going to call this log handler. Okay, and so we're going to return, actually, this is where we're going to need a class, right? Runtime value optional of, we're going to need a class, we're going to call it a new demo log handler. So I don't have this class, but we should get it generated for us, hopefully. No. No worries.
It's amazing how IDEs fail to cooperate.
No worries.
When people are watching.
We'll just do it the hard way. Can't create. Oh, sorry. Yeah. This was supposed to be called recorder. That's why I can't. Yeah. So it was my fault, not the IDEs. Recorder. And then this will be called handler here. And now, there we go. See?
Yay.
I was dumber than the IDE. This will simply extend the JDK's handler, log handler, where is it? Java util logging handler, yes. And we just want to override the publish method, and what we're going to do here is say, we're just going to do, for this, at this point, all we're going to do is system out, and we are just going to say demo, and we're going to print the actual record, which we'll get by saying log message is string format record get message and record. Oops. Good thing I have all the shortcuts because it's pretty hard to type like this. Okay.
For Georgios' next trick, he's going to do the whole demo blindfolded.
Okay, so I think we're good here. For this part, all we're doing is like we're intercepting the log messages, and we're just going to write the same message, but with this demo thing up front, right? So we have our logging recorder. It's actually creating this handler. Excellent. And what we do now is here we're going to need this recorder. So we're going to say log, not demo log. Demo log recorder. We're going to call it recorder. And we're going to say here log handler, and this should work, I hope. Okay, oh, we already have a build step, we already have all that stuff. Excellent, we already have it here, blah, blah. Okay, so now let's let's package the extension to make it available locally. Oops, where am I? Yeah, anyway.
And so normally if you're developing an application on Quakus, it will hot reload. If you're developing an extension,
yeah, that's the problem.
It's not optimized for the extension.
You don't get as much Quarkx love, but yeah, it's okay, now we need to start the test application, which I said, as we said, it's just a to-do application, but it needs a database. We could have used dev services here, but let's just oh wow. Yeah, okay. Ambient Quark, all right, making it even harder. Ambient Quarkx dev, okay. So let's see. Now what I'm hoping to see wasn't that, obviously. So what's the error, blah, blah, blah. Let's see what we're doing here.
Oh, we did have some of the logging coming out, though. I saw the eye catcher for it. Now this is going to be hard to get to the class not found demo. Oh wow. Oh, I know what the problem is. Okay. Yeah, the problem is that I hadn't cleaned the previous thing. Well, when I was doing the demo run of the trial, I had all the code in there already written, and now like Maven's not smart enough to delete the code that you've
deleted. So we need to clean manually. That's for people who say like you should never run Maven clean, which is absolutely false. There are
I think
cases.
the lesson is that you should never practice your demo.
That's a good lesson, yeah. Okay, so let's see where we are. Yes, excellent. So every logging we had is now prepended with this demo thing, right? Which is exactly what we wanted.
Cool.
And let's see the local host. Let's see the application itself. So yeah, this is just a to-do application. It was logging like redirect somewhere. So yeah, we just intercepted it and said demo, right? That's not too interesting, is it?
No, I mean, we're only seeing the logging that's already there. What if I forgot to add any logging? What if I want to see what's happening with my application?
So the idea is we'll probably want to ship it somewhere, right?
Yeah.
Okay, so what we'll have to do is let's start by saying, okay, let's create a client, Java class, demo log client. So what this will do basically is we'll ship it. We'll be using like a REST call that, let's suppose there's like a REST service somewhere that
My
is
observability solution.
Yeah, the custom like in-house observability solution, and it's very simple. All it does is like have 3 endpoints where we ship logs to it or events or something like that, right? So we want to create a client. I'll do this very manually.
Lesson 1 of the cloud is you've always got to send your logs somewhere else other than localhost.
Or somebody's going to be really unhappy. So now here's the configuration for our extension, right? So Holly mentioned earlier that extensions usually need to be configurable in order to like be general for a lot of applications, right? So since we're writing this extension, we want to make sure that it can be used in different ways. So like if our observability solution like moves to some like other URL, we want to make sure that it continues to work, right? The extent the applications can continue to work. So, oops. So what we're going to do here is we're just going to say public string. If I could type string, that'd be cool. String base URL, and I'm just going to say whatever for now to save time. Demo client. Okay, so we're going to use this configuration here. And we're going to get it. Quarkx is going to inject this configuration. Oh, sorry, not log client, log config. Demo config is what we called it. OK, fine. Demo. Config. Excellent. OK.
Well, I think you need to go to touch typing lessons.
OK, let's see. Config. Cool. OK, so Quarkx is going to allow us to inject this configuration that we wrote earlier via CDI, right? So that's super useful. So we have constructor injection here, which is super useful. And I'm going to use the JAX-RS client. So I'm going to say private final client, which is the JAX-RS client. And I'm going to say this client is client builder, new client. Excellent. Right. OK, so what do we want to do? Basically, we want to add a method that will just ship the log, right? That's
cool. Yeah.
our initial goal. So let's call it log string message. And we are going to use the client. Actually, I have no idea how much time we have.
So we've got 5 minutes, 6 minutes.
Oh, wow. That's cool. OK, so we're going to say client, target, config, base URL, and request media type. It's going to be a text. And this is, the logs are post, I think, right? Yes, post entity text message.
Yeah.
And that will just ship it off. I'm not going to care about the exception at this point. Also, what we want to do is, though, we said earlier that we want to intercept the GET request, right? So let's go ahead and do that as well. And the way we're going to do that is by adding a public void event method here. Event. And let's just copy and paste this for now. And we're going to say, we don't have a path.
I think we missed a path in there.
Yes,
yeah.
yes, very true. We missed the path here and here. Path is log. Okay, so this is request, blah, 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 but this is going to be a get. No, not there. Definitely not there. Get class. All right, I can't see anything, but that's cool. String dot class.
Cool.
Okay, home. So yeah, now we're going to need introduce local variable, event, okay, S out, demo, event response, event. Okay, so that's just going to be the client shipping off. This is shipping off the interception of the GET request, right? But we haven't actually done the interception of the GET request. So we're going to use a CDI interceptor, which we're going to go call demo. Oh, sorry, this is Java class. Demo log interceptor. It's going to be a CDI interceptor. So interceptor. Oh, we still need we need the annotation. We need an annotation that will allow us to use this interceptor. Demo log. It's an annotation. I'm pretty sure I have all the cool stuff that we need here. So yeah, this is just basically the idea here is that any method that's annotated with demo log we'll call the demo log interceptor. But there will be no method annotated with demo log. What we'll do is that we will magically add the annotation to methods that are annotated with get, right? That's the big idea.
So rather than having to go through and add an annotation to everything in our estate, which would be really tedious, we can just say, I want everything intercepted.
Exactly. So there's 300 applications. We don't want to have to go everywhere and say like demo log. We want to magically add it, right?
Yeah.
So demo log, excellent, and we'll say public object around.
I think it's around invoke. Oh no,
the round
that's
invoke.
the annotation.
Yeah, exactly. Invocation context get method. So we're getting the method here that we are going to use. We're going to say s out demo intercepting method get name. Yes, excellent. And now we're going to ship it off. We need to ship it off to our custom observability solution, and we'll do that by saying private final demo. We're going to reuse the demo, the client we have, and again, this is CDI enabled, so we'll use constructor injection. We're printing it, and then we go demo client, and say client dot event. Excellent. Cool. So we've written that part, right? Or I think I'm definitely missing something.
Do we need to do anything to the processor?
Yes, yes, we do. But before that, I need to figure out what the error is here because, excuse me? Ah, yes, I'm not returning. You're right. Very correct, yes.
I think you need to do proceed as well.
Yeah, yeah.
You?
Context, proceed. And I need to throw the exception. Fine, yeah. So it's just a CDI interceptor that will offload, will hit our observability solution and we'll proceed, right? So now we, exactly as you mentioned earlier, this code is not really knowable. Quarkx doesn't know about it. So we need to make it known to Quarkx. And we'll do that by adding public, as you showed earlier, the additional bean build item.
So is this adding stuff to the index?
Yes. It's adding stuff to the CDI index to be precise, yeah. And oops, there's a builder here, and we will say add bean classes. And which bean classes do we need? We want the client, the demo log client class, and the demo log interceptor class. Excellent. We'll make these unremovable. So Quarkx also has this notion of that it removes CDI beans when it thinks that they're not used. So that saves a lot of space and a lot of memory and startup time. But we need to, in this case, we need to tell it that the demo client and the log interceptor are being used. Okay, so we've done that, and now here's the real magic. The real magic is, like we said, we wanted to make the JAX-RS get annotation. We wanted to let's say change the code. So every time we see a get annotation, we want to add the demo log annotation, right?
Cool.
And Quarkx has this amazing build item that does that, which is called a annotation build item transformer. So what that does essentially is that it allows you to make arbitrary annotation transformations on CDI beans. So we will just add a transformer here, and we will say if transformation context get annotations stream any match AI, not AI as we hear it in the news, but it's good enough for this particular instance. AI name. So we basically want to make sure that we're only transforming things that are the JAX-RS get, right? So get class, get name. So if we find the name annotation, what we want to do is, oh, right, yes, very correct. Dot name create simple. Thank you. Okay, here we go. Transformation context. We want to go ahead and transform it by adding the demo log annotation, and it's
was it the demo log interceptor?
No, the annotation. We want to add the annotation because the interceptor gets added automatically when Arc figures out what's going on. So yeah, I think we're not good here because we need this because we're in Java and not like Kotlin or something. What? Excuse me? I can't hear you. Done. Oh wow, yeah. Oh, that would really mess things up. Yes, done. Thank you. Thank you very much. Okay, now let's see if this actually works, right?
Cool, yeah. We're 4 minutes over, so I have to hope that it works or we're in trouble.
Yeah, or else this is for nothing. Okay, so what I want to do, oh, wow. You know what else I forgot to do? I forgot to start the magic part, which is this. Okay, so let's see where we are with the application. Okay, the extension got installed, and now we need to restart the application because obviously, you got a glimpse of our custom
yeah, so what
observability
is this
solution.
observability client?
So yeah, well, you should explain the use case more since it was the boss who requested it.
Yeah, so I think the boss has the mental age of a 10-year-old, and everything has to be surfaced to him through Minecraft, which is unfortunate because we have 300 applications to instrument to do Minecraft as an observability solution. Basically, if it's not in Minecraft, it doesn't exist for him.
So yeah, basically he wants to see when our applications are hit. He wants to see something happening in Minecraft, right? Which is pretty weird, but you know, people. And yeah, I messed up. I didn't say where our observability solution is, or the default is, basically. Localhost 8081 observability.
Oh, I don't think that's right.
No, yeah, you're right. Observability. Okay, hopefully this time we'll do better. Excellent. So the application is starting. Yeah. Oh, you gotta be kidding me. I done.
It's not like you just had this up.
Yeah, it's not like we just tried it earlier, like an hour or so ago. Wow. Well, at least the Wi-Fi is real fast.
Yeah.
Excuse me? You know what? I've never touched Minecraft before this demo. So I knew what it was, but that was about it.
And see, now you're never going to touch it again.
Yeah, since it messed with us so much. Okay, where'd it go?
I think there's like a pause, and then it'll sort of come back, hopefully.
Woo.
Yay.
Weren't we at 118.2 just like an hour ago?
Oh.
In the space of an hour, it updated? Yeah, that's wonderful.
Cool. No.
Of course. Please use 118.2. Thanks. Yeah, sorry about that, but I just tried it. We just tried it an hour ago. I mean, it's insane.
Right, now's when. No, I think we're not going to have time because we're 8 minutes over. That's so sad.
Sorry, we're really sorry about this. But
yeah, the lesson is that you need to go somewhere that doesn't have network, so it doesn't do the update.
Yeah, I mean, I can't believe this. This is. You usually want Wi-Fi to be working. In this case, I guess you don't. Anyway, so you want to finish here with?
Yeah, I think we can just really sadly explain what you would have seen. Oh, it's so sad. I'll post screenshots because it was really cute. What you can see is you can see all the Quarkx logging coming out in Minecraft. So you see it listing what extensions it does and stuff. And then when you hit the REST endpoint, it does a lightning bolt, and then it spawns a chicken. And the chicken shows the timestamp. Because if you were doing it in production, obviously, you wouldn't just show the timestamp. You'd have something like the IP address of whatever was hitting the endpoint. But because this isn't production, we just put the timestamp on the chicken. And if you get an error, the chicken explodes. And then it sometimes... The problems that we thought we would have with the demo is that the exploding chicken sometimes kills you if you're too close to the chicken, and then you have to respawn. But we didn't anticipate that Minecraft would update itself and lose its compatibility.
Yeah, we need to keep that in mind for next time.
Yeah, and the last thing that we we haven't talked about is if you want to do something to make it work with GraalVM, you might need to go a little bit deeper. You might need to do some substitutions and telling it about reflection and that kind of thing. But that's all documented if you do go that far. So with that, thank you very much. I'm really sorry we didn't get exploding chickens. And thank you very much for your attention on the last day of the last session.
Thank you for coming. Any questions? We're available probably like after because we're already over time. Yeah. You want to come make Minecraft work?
Yeah, yeah, I can do it. I've probably got it on my machine.
Yeah, go ahead.
Right.
Oh.
Any questions? Is that a question at the back, or is that someone stretching? Someone going, I'm sure there's beer. Please let me go. Yeah, I think we better let everybody go.
Okay.
If anybody does want to see it, I'll get it up, and we can show it without everybody waiting and watching and wishing we were beer. So thank you all again.
Thanks again.